Hello everyone, good morning. Great. How are you doing, guys? All good. Excited for Sunday's class, and we are approaching towards the end of 5 as well. Cool. Awesome, awesome. Yeah, and it's a challenge day as well. So by end of the class, yes, I will be sharing a challenge as well. And yesterday I already talked about it. So you know what to do with the challenge and where to submit it. All those things will be floated over the mail where you need to do the submissions and all. And the folks who are joining our classes for the very first time, so don't worry for anything, right? If you're not able to catch, because whatever previous classes we have taken, all those recordings are present on the dashboard. You would have got the access. If not, then check with the team once, contact the team, support team. They will grant you the access, all the assignments, all the tasks, whatever we have done so far, and the recordings, the previous class recordings are present. So if it is your day one, or you are starting from the day zero, then start with that one. An announcement for the lab environment. So guys, we are really working hard on it. And again, I said, this is not just only for one student. iNeuron is like mentoring like thousands of students. So we need to make sure that this integration, because everything needs to be integrated on the portal and it should be working fine. So the team is working really hard day and night to make it happen, right? So just allow us a week or so time, so that everything will be available and we have guaranteed. So that means it will come for you. It is not like that we just announced and things will not be available for you. It's just backend team is really working hard on it to integrate the things smoothly, so that things don't break when you are using the lab environment. And so far, like whatever we are doing and practicing, so make sure you are doing it in your local. And as soon as the lab environment will be available, you guys simply right need to use the lab environment and work on it. That's it, right? And we will be having a Q&A session as well. But now first I'm going to start with the topics, right? So I'll reiterate on the yesterday's topic, and then I will move on to the today's agenda, that what we are going to study. So our today's focus will be more basically what I'm going to talk about first. Few things, right? Yesterday we talked about the serialization, deserializations. Today we will see its practical implementation, the CSV and JSON survey. And the I will show you few commands so that you can internally look, okay, what kind of serialization and deserialization particular table and data set is using. And then we'll look something around the setting the number of mapper tasks, right? All those things will be running few queries, and we'll show you some cool things on Hive, right? And then we'll move on to the UDF part, the partitioning, bucketing, and the mapping and joins, all those things. So which batch is this? This is the batch one. All right, so let me share my screen. Just a second, let me share my screen. Let me clean up my pages. Just a second, guys. All right, cool. So let me add a few pages here, and let me know once my screen is visible in the chat box. a second. I hope screen is visible. Awesome, cool. So I'll reiterate from yesterday's part, right? Whatever we talked yesterday, and it was related to the serialization and deserialization. So how that was happening. Serialization means converting object into bytes. And deserialization, what does it mean? Converting bytes into object, right? So yesterday we talked about all these things, that how these things will be taken care by Hive internally. Okay. And today we will be looking at different serialization, deserialization, implementation, how to do that in Hive itself, right? And since we have seen it, now what I will do, whatever tables we created yesterday, right, the ORC table, right, and the CSV table and the Parquet table, that is something where I will show you few commands so that you can check, okay, what kind of serialization and deserialization technique that particular thing is actually using, right? So let me just open that one. First, let me connect on my terminal. Okay, it is already connected. Great. Let me share back my screen. Okay, so I hope this terminal is visible to each and everyone. So first, open the Hive terminal. Right. So Hive terminal is open, and yesterday I created a one database. So use database right? And now I will run a show tables command. So, okay, and not this one, use Hive class B1 show tables. All right, so Parquet files, right? The sales data, Parquet final, right? So that was something which we created. So let's try to query it once, that yes, it is still working. Right? So yes, we can see the data. Now there is a command we will run. So describe formatted and our table name. Okay. So now this is the point where I want you everyone to focus, and also make sure you note this command as well. Already in the first class, I talked about it, what is the purpose and why we eventually use this describe formatted and the table name, because it gives the whole idea or the complete metadata of any particular Hive table. It will include how many columns are there in that particular table, its data type, apart from that, in which database this table is, who is the owner, when it was created, and in the warehouse, what would be the location of the data where it is stored, right? Whether it is a internal table or the external table. Internal means managed as well, and few stats about the table as well, like the number of files, number of rows, raw data size, right, in the bytes, total size, all these things will be there. Now, this is the interesting point which you guys need to focus, right? So Serde library, input format and output format. So if you read this thing, Hadoop, Hive, QL, IO, Parquet, map reduce Parquet input format and Parquet output format. And then here you can see this library is used Serde, Parquet, Hive, this serialization and deserialization. So I'll again go back to the sheet and I will explain that what this input and output format, whenever we talk about the serialization, deserialization, so it will be like input format. Like in the describe command, we saw that we are using Parquet, Serde, and output format Parquet, Serde, right? And the Serde library is which is mentioned here, and this is like Parquet Hive Serde. Right? So this is used here. So what this actually means, or the serialization, deserialization we were talking about, right? So let's say there you have a table or data which you serialized, right? Serialized with class A, right? Or you serialized this data with any specific format. You use this part, right, or template to serialize this particular data. Now let's say you are transmitting this data to somewhere else, right? And here what you are trying to do, you are trying to deserialize it with the help of class B, right? So obviously this will not work, because whatever thing or whatever template format we used to serialize the source data, same can be only used to deserialize the data. That is how the whole data compatibility will be maintained. So when we talk about the serialization, deserialization in Hive, so a few things directly depends on the mapper reducer task as well, right? Because we ultimately know in Hive what will happen, whatever SQL query we will be writing, or not SQL, we can say the HQL Hive query languages will get converted into map reduce task, right? And this thing we have seen in the terminal as well while running the queries. So HQL will get converted into a map reduce task, correct? So map reduce, as we already talked about, right? In the day one, I was explaining how the map task work and how the reduce task work. So map task, right? This will be, let's say, mapper task, map function, right? And this will be our reduce function, correct? So mapper, what they will be doing, they will be reading data from the HDFS, right? Read. And then some computation will be happening here, right? Map will be doing some computation and intermediate output will be written on this layer, right? And from here, this reducer will read the intermediate data and final computed output, whatever it is, right? It will write it in the HDFS, right? So this is how, right? The step one, this is step two, computation, and this is step three, right? So when we see this thing, right, the input format and output format, right? Let's say any Hive table we have created, which is stored as some specific file format, let's say Parquet, ORC, or the CSV, then you will see this thing, input format and output format, right? So input format, output format means, first of all, let's say whatever Hive table you have created and whatever data is going to be dumped and whatever data will be stored in the warehouse, its specific form in the HDFS will be Parquet, right? So now in this case, since it is mentioned here, the input format is mapred parquet input format. So this is a indication for the mapper task, right? Whenever we declare all these things, right, while creating a table, yesterday we saw this keyword, right? While creating a hive table, we used stored as parquet, and I given you guys a task to work something on the ORC, right? So here we can use stored as ORC as well, right? So when we write this thing while creating our hive tables, so these things will be captured in the metadata itself, right? Okay, whatever data will be dumped into particular hive table, so under the hood in the HDFS, that will be written in the Parquet serialized form, right? So now this data is being read from here, like mapper task is reading this data, right? So this mapper task and this reducer task both should have some kind of libraries or mechanism available to deal with this Parquet file format, right? Because every file format had its own way of storing the data, its own way of compressing the data and these things. So these are the programs and these are the methods. So if they don't have any such kind of libraries, for an example library, when I'm talking about, let's say you want to write a program, right, to manipulate the data and create a dashboard for it, right? Just a simple example, let's say the matplotlib or any kind of library. So without those libraries, right, you won't be able to use such kind of methods which can create a dashboard like line chart, pie chart for you. So similarly, to deal with these kind of specific serialized, deserialized format, their respective library should be there, right? And these things will always be present in the Hadoop ecosystem, or you can say whenever you will install the Hadoop and you will set up the whole Hadoop, so those libraries will come as a bundle and as a package in while you can say setting up the Hadoop itself, right? So that is why I'm saying here the input map read format which is mentioned here, that means when map task is reading the data, right? So the input format which map task need to use should be the Parquet, right? So read Parquet, and this is the meaning, right? Whatever is written on this line, this is the whole meaning, whatever I talked about. So indication to map task that whatever data you are reading from HDFS, that is in Parquet. Now whatever library is written here, like Serde serialization, deserialization library, so you can see these are the default. So yesterday when we were creating our table, we didn't mention any specific serialized, deserialized libraries, right? This is something by default has been taken care by Hive itself. So whenever we used stored as Parquet, stored as ORC, Hive itself got to know that, okay, what kind of Serde library I need to use in order to deal with Parquet file format or ORC file format, right? So that is why the mapper task, which will be created by Hive engine, and the reducer task, which will be created by the Hive engine, this Parquet Serde this Parquet Serde, you can say library will be added in the mapper task and the reducer task. So whatever record we are reading from the HDFS, those will be tackled with the help of the library and the computation will be done. Intermediate output will be written to this layer, and reducer will consume this intermediate output, will perform final aggregation. And while writing it, right, while writing it, you can see this line or output format keyword will help the reducer to get the information that the final output, the aggregated output which I'm writing to HDFS, in which format it should go. And here we can see in the output format, it is clearly mentioned MapReds Parquet output format. So reducer will use the Parquet Serde library, right, to serialize the data in the Parquet format and dump into the HDFS path. So that is how the whole, you can say, map reduce in Hive works along with the serializations and the deserializations part, right? So I think now this should be pretty much clear to you all that how this is working, at least even from the theoretical perspective. Now you know what command you actually need to use, this one, right? The describe formatted. And now today, first thing we will be doing, we will see two more examples for the survey, one for the CSV and one for the JSON. So now let me implement that one. I can see questions. So what exactly map reduce ETL or something else? Can you explain the library part once? So library part, again, the way I was explaining, if you have something very specific to deal with, and in any programming language, in any, you can say framework, so you need a library support. Library is nothing, again, a bundle of programs, right, which you can simply import and you can start writing your own things. It's not like even to deal with those specific things you need to write your own specific code. And question, what yes, like C++ or Java, and similarly in Python, right? We have so many library supports like pandas, NumPy, right? You would have heard about machine learning libraries. So those libraries are nothing that the bundled program where you just need to use the method, right? Don't need to write the whole program from scratch. Is serialization deserialization works on same time? No, it can never work at a same time, right? Serialization, when it is happening, when we are storing our data and when we are basically putting our data in a specific format into our source or destination locations, then that means we are serializing it. And when we are reading it, so this thing in detail I explained it in yesterday's class, that how it is happening, so you can revisit that part. So yes, by default, whatever file formats are supported, let's say the Parquet, ORC, and all these things, so Hive will itself decide the which survey it needs to be used. But there are other packages as well, right? Which we need to mention, that sort of library we need to mention, for example, the CSV and the JSON. So that time when we are dealing with those kind of datas, then we need to mention the survey library by our own while creating the table itself. So I didn't import anything. I will tell you that how it will be imported, right? So just wait for a second. Nothing too much complex to understand here. And just a second, let me explain that CSV survey part and you will get the idea that how it is being done. So, Kiran, now you should answer this question: why we are able to select data from Parquet table, as we created this table by importing CSV table data. If you not sure if you were there in the yesterday's class, but these things were definitely talked in depth and in detail. All these codes will be uploaded to GitHub repository. Yes, it will be uploaded, right? And so far I have been sharing all these things. Let's say if you don't have a link, then just give me a second. I will again share the GitHub repo link, right? So whatever we have talked so far, right? Whatever we have studied so far, here is the link, right? Classes wise, and I will create a doc for today's class as well. So here I have shared the GitHub repo link, right? All these things will be there. And all these commands, Samida, I am writing it on a lab environment. So you can see the classes from the day one. So there where we talked about the whole setup part. So make sure you watch it and do a setup in your local, or else wait for a week so that lab environment is available to you all and you can directly practice it there. Let me create a new file for today's class as well. So Hive class 4.txt. And so first thing what we learned today is this thing, the describe command, right? So use this one to get details about the, use this command to get details about serialization and serialization, right? This is done, and now let me work on this thing. All right, so first what I'm going to do, I am going to create a small dummy data, right, for you, and we'll share that one as well in the GitHub repo, and that will be basically the CSV data. So let me first do exit from here, and let me create a simple data for you all. So this thing, CSV file, and this CSV file, right, will be pretty much different from the normal ones, right, which we have used so far, right? And I will tell you how it looks a little bit different. So here, right, what I'm going to do, I am going to use this thing. Let's say the header row will be there. So yesterday somebody asked this question as well. Let's say what will happen if header row is also a part of our raw data. So today I will show that part as well. If there is in your raw data, if your first row is basically a column name, then how you can actually skip it, right? So name, and another will be the location, right? So these are nothing, basically the our column names, right? And after that, in the name, what I'm going to do, I'm going to write this one, Amit. And then for the location, it's say, let's say Bangalore, comma, India, right? And another, let's say Shashank. Now let me know where I live. What is my office location? Gurgaon, right? So this is the data, right? We have created a dummy data. Now a quick question from you all. Just let me know in the chat box what kind of difference you can see, right? So far, whatever CSV data we were dealing with or working with, any small minor difference you can see in this one? Double quotes, nested, location has two values. Yes, great. I'm glad to see that you guys are noticing the small and minor things, right? Yep. So two strings, right, in the double quotes. So normally whatever we have, the CSV files we have used, so their delimiter was, let's say, used as a comma, okay? And that was something which we were using, right, in the while creating a table, let's say fields terminated by comma. Right now here we can see in our data, right, for one of the column values, comma has become a part of value, right? So now it would be pretty much difficult for the, normal create commands we write, right? Normal create commands which we use while creating the tables, it would be pretty much difficult for it to figure out that how to deal with this kind of situation where the delimiter is itself a part of the value, correct? So now this is kind of custom data for ourselves, right? This is a custom raw data for us, we need a custom, you can say serialization, deserialization technique, so that whatever definition we will be using while creating our table, right, same definition will be used while deserializing the data as well, right? And that is the point where our serialization, deserialization, you can say libraries will come into the picture, because those will allow us to specify these kind of properties where how we can deal with these kind of scenarios, right? So that is how the importance of, you can say, the importance of surveys will come into picture. Now once I will create one table, right, then you will get the clear idea. We can use struct also not to deal with it, but struct, they, that is something, right? Why even to do that? My question is, you can do it completely fine, right? But if you have a support of the library itself, which can do it for you very, very easily without even taking so much headache of defining structs, multiple time arrays, or multiple type map type of right data types. Why to take that kind of headache if we have the great support of the serializations and deserializations, right? Just simply use that one and define the properties, and we are pretty much sorted, right? So that is the whole thing to mention. So now this data has been prepared, and now let me just copy it into the local. So cp csv file data csv, so temp hive class, right? Now it is here. And so again, if I open my Hive terminal, cool. So now this is something where I will use our database Hive class, right? Hive class B1, and there we will try to create a table with serialization and deserialization properties. Okay, so create table, CSV table, right? And here we will give the column names. So name, string, and another column will be the location string, right? Now I will write one line first, and then I will explain row format survey, and the library we are going to use org. Actually, and don't worry, right? You don't need to remember all those library names every time. Even sometimes you forget about it, just Google it, you will get the idea. Okay, for CSV, which library I need to use in the create command, and same goes for the JSON as well, right? Nobody can remember that whole lengthy library name packages, right? So that is completely fine. Hadoop Hive survey2.open CSV survey, right? So row format survey org.apache.hadoop.hive survey2.open CSV survey, right? So let me take a pause here, and again I'll go back to this thing. So in the create command, right, what we mentioned, so earlier, let's say what we were saying, row format, when we were uploading the normal, you can say files, right, delimited, right? When we were storing normal .csv files where our comma was the delimiter, and everything was pretty much sorted for us, right? And we didn't need to use any external survey library and all these things, correct? But now in this case, right, when I'm writing this part row format survey, and I have used some library here, correct? So how it is going to happen here? That means it is a indication for Hive that the incoming data, right, the incoming data is something which is not a normal CSV. Its type is CSV, but the data which is stored in this even .csv file is in a specific format, right? It might have some nested quotes, right? It might have the nested delimiters, right? And all these things will be there. So this is something now, since raw data is something which is in a specific format, and to deal with that one, we need to define few properties, and few properties as in there should be a library support which will capture those uh, properties and parse the incoming data or the raw data accordingly, right? So this library which we will mention here, the main task of that one will be parse the raw data, right? Parse the raw data, and it will be a responsibility of Survey library. Parse the data means parsing it simply. It was stored as a normal text or something. Just read it and parse that data according to the library which has been mentioned here, right? So in this command, if you see, I have used that Survey library, open CSV Survey, right? This is the library I have used. So now it is an indication for Hive that the incoming raw data is in some specific format, and after that there will be few properties will be defined. So whatever serialized data or normal text data I am reading from the HDFS, I need to use these properties and libraries in order to create a proper row object, right? So whatever let's say whenever we fire this select star command, right? Select star from employee table, right? So few data values will be printed, right? Let's say name will be printed, and then salary will be printed. So this is something again which is in the readable form for us, right? We can read it and we can understand it. So whatever we see on our terminal, that is a deserialized object itself, deserialized object. And that object is nothing, basically a row object, right? Deserialized object, and that will be known as the row. So that is whatever line we have mentioned here. So it is an indication for Hive that whenever you are reading the data, right? Whenever you are reading the data and displaying it for the deserialization, that means you need to use this library and properties defined during the table creation part and create an object accordingly, right? Now, if I go back here, so this part is pretty much clear to you that the deserialization, how it will happen, which library will be used, and what this row format particularly means. That means whatever serialized data is stored or serialized data will be dumped into this CSV table, while reading it and while consuming it, the deserialization will happen using this library, and whatever data or object will be created, that is nothing, basically our row object, which actually gets displayed over the screen, right? So this line has been declared, and now the most important part which I was talking about, these Survey libraries will give you a support of properties which you can define, and those properties are nothing, again a indication for the Hive engine that whatever raw data is stored or whatever raw data we are reading, please follow these specific format or please follow these specific properties, right, while parsing the raw data. And what will be those properties and how we can define it? The keywords which we need to use with Survey properties, right? Just a second, there should be a space. So with Survey properties, and there will be a parenthesis, right? And in the parenthesis, what we need to do, we need to define first property. And now you can see, right, when I'm using these keywords, you cannot use it normally. I mean, let's say I am creating a CSV table and I'm not using any custom surveys and all, then you cannot define these properties, because these use of these properties will eventually come into picture when we have a custom data to deal with. And we need custom properties as well to just parse that data, and that is why this thing will come into picture. So the first property we need to use separator character, right? Separator character means whatever raw data we have in that raw data, which field or which character will be used as a separator. Separator means to separate the fields, right? And that will be our comma, right? So first property we have defined. Now second property, that is the quote character. So this is a very generic behavior. I'm not saying very specific to Hive and all. This is something related to the different datas and the files. So in CSV, when we use this term like the quote character, so how it will be defined, right? It will be defined as the this double quote, right? So after the backward or the this backslash, whatever I have used, let me explain it right here as well. So see, what will actually happen if you have written something in the double quotes, right? If you have written something in the double quotes, right, you can let's say simply write Shashank here, right? This is in the double quotes. And now let's say you want to use double quotes, right? Double quotes as a part of Shashank string as well, right? And to define this value, right, that Shashank is kind of a string, you are already using this sort of double quotes. So without using any specific character, you cannot make a part of these double quotes of this original string. So for that one, in order to declare such thing, we use backward slash, right? And this will be the indication of the you can say somehow the escape character. So in that way, whatever will happen and whatever will be what actually it is meant for, let's say in our raw data there is any string, right? And that string somehow contains the delimiter itself, like the same comma which is being used as a separator, if that comma is a part of string value itself, right? So we need to define that how to deal with these kind of situation. For that one, we will notify our Hive that any string which is quoted with the double quotes, right? That means if delimiter or the separator character is a part of that string, so don't use or don't consider that comma as a delimiter or separator. Use and consider that comma as a part of a string, correct? So that is the whole purpose of having the quote char. Quote char means simply that if any column which is of a string type and in that column comma has become a part of value itself, and since comma is our delimiter as well, separator as well, so that string value should be should basically contained in a double quotes, right? So that it can be passed successfully, correct? So that is why the input data which I showed you, right? I will quickly go back, right, and will upload that data for you. But again, simply it was there, right, in the location column in the double quotes, what we written Bangalore comma India. So comma was part of that string as well. We shouldn't consider it as a delimiter. If we wouldn't have used this library or the custom survey properties, then with the normal CSVs, right, or normal create tables, we would not be able to parse that raw data. That is why this survey and their properties are very much important. So this is the second property, and third property will be the escape character. Right, escape character. And what will be that one? Backslash. Right. Now the question will be, what is this escape character? So here what we talked about, let's say this is the double quote and Shashank Mishra, right? And simply. So quote care we have already understood, right? Quote care means backslash is basically why I used it. So let's say you are writing two double quotes, and within that you want to use one more double quotes. So your Hive engine or any kind of compiler will get confused that whether I should use this one or whether I should use this one, right? Because everything looks completely same, right? Although we use three double quotes, but compiler will get confused. So compiler needs some kind of indication that what kind of special character is being used for the quote character or as a escape character. So whenever we are writing, right, let's say double quotes I was using here, let's say this double quote I used to notify that within this one comma is defined, right? And comma will be used as a delimiter character, right? So character string type, that is why I use a double quote for the notation. Now let's say I have this double quote, and as a quote character I wanted to use this one, and now over the terminal I want to write it. So I need to use the backslash, right? Backslash with extra this double quote, because this double quote, how I wanted to be defined, I wanted to be defined as this one. But if I directly write this thing, our compiler will get confused that I should use this one or this part. So that is why how it should be written this way: double quotes first and then use a backslash and then double quotes, so that this will be treated as a special character, and that can be easily handled with the parsing. So quote character is understood. Now talking about the escape character, right? So escape character, again double forward slash. So forward slash, sorry, the backward slash, here we are using it, it is a special character. So always to make a special character part of value itself, right, we need to use this backslash, so that whatever next value we have used, that will be treated as a char or the string as well, not a special character. So what this escape character means, so here we got this idea, but what is the condition if we want to make double quotes as a part of the string as well, right? String value. So let's say what output we want. First let me write the output. Let's say I want one output on my screen: Shashank Mishra, and in the bracket DE, right? That means the data engineer. I want this thing to be printed on my screen, right? If I simply write thing in this way, Shashank Mishra, DE, and again this code, right? So again, my compiler or Hive engine will not be able to understand this thing, that how should I deal with this double quotes, because these double quotes I am already using as a quote character, right, to deal with the delimiters which are part of the string value itself, right? So in this case we need to use a escape character. So the way your data, the raw data should be presented, if the double quotes are part of your string as well, then how this value should be mentioned in the raw file, it should be mentioned in this way: Shashank comma Mishra, and then backward slash double quotes DE, then again backward slash this one and this double slash. So now if this line is written in the raw data and we have correctly mentioned this property and this property in our survey properties, so the outcome of this one, the outcome of this raw data will be this one. Because this escape character, which is one backward slash is a notification for the Hive engine. Whatever character will be written after it, it will not be treated as a special character. It will be treated as a normal string. That is how we were able to achieve it, right? So this part is also understood. And now we have successfully defined our most of the properties of the Saturday properties, and we will close the uh, output, or we will close our properties. And after that, let me simply store it as a text file. This is also one of the type here, right? The way we use the Parquet ORC, and here text file means simply whatever data will get written in the output, it will be a plain text file, not any Parquet or that kind of serialized thing, right? But Parquet or serialized as in means the data which is going into the you can say the HDFS warehouse, that will be CSV serialized and deserialized based on this one. But for the storing, the format will be used, it will be a text file. And now in the beginning, I mentioned that part was the header was the part of the data itself, right? So for that one, how that can be tackled, for that one specific keyword can be used in the create command, which is table properties, right? So table properties, and in this one, what we can mention, we can, right, mention this thing, skip header dot line dot count equals to 1, right? So what this means, that whatever data we are going to store in this particular table, this table has one property, and that property is like skip dot header dot line dot count, and that is equals to 1. So whatever line number 1 in the raw data, right, that will be treated as a header, and we need to skip it, right? So that will not be coming into the picture when we will create our table, right? So now let me create it. So our table has been created. Now let's quickly run a describe formatted command to see that what all things we can see into this one, right? Describe formatted, right? So here you can see all those things, properties which we defined, the simple name and location, then other things, right? And most important thing we need to look at here, the input part, right? The data which has gone into the file, or which has been stored into the HDFS warehouse, that is plain text, right? Nothing complex to understand. And when the output will be generated, right? So the output will be generated, ignore key text output format. That means simply first we define the table property. So there will be one header row which needs to be ignored. And this text output format means the input, the data which we stored, it was a plain text we stored, right? Nothing in a different format or anything like that. And the output which is getting generated, that is also sort of the text form. But the row which will be displayed, or the objects which will be created for the computation, calculation, and the display, right, that will be deserialized based on this thing, right? So for input output format, don't get confused, this is an input output format for the map and reduce task, right? What kind of format it will pick from the HDFS while reading the data, and what kind of format they will use while storing the data and creating the output. But in between, whatever serialization and deserialization will be happening for the raw data, that will be done with the help of this CSV survey, CSV serialization and deserialization. And here you can see properties as well, what kind of properties we defined in our surveys, right? The escape character, code character, and separator character. So now these things are done. The table part has been created. Now quickly, I will basically load some data into it. So load data local in path file tmp Hive class CSV table dot CSV into table this. I have copied this data to here. CP CSV file dot CSV temp hive class. Oh, CSV, not CSV table, it is CSV file. Right, so now this data is getting loaded. Now let's set one property, set hive dot CLI dot header dot print equals to true. And now let's run a select query, select star from CSV table. Cool. So here we can see, we can even see our output, right? Amit, Shashank, and Gurgaon, India, right? Else, if this was, let's say, not handled properly, right? We wouldn't have defined our serializer and deserializer, right? And the properties, then obviously, right? This kind of output we cannot expect, right? This delimiter would have acted in a different way, right? And the output will be something, right? It will not be a proper way, and even we will not be able to read the data, right? So that is the big challenge. And I think now that should be able to understand. So the question is, for next record, how delimiter is used. So delimiter, right? That is something which we define in the properties itself, right? So the properties, right? If you can look at this part, the separator character delimiter, but the quote character, right? Quote character means if there is any string where delimiter is the part of the main string as well, right? So brief will again take a time, quote character, escape character. I know it is pretty much confusing, but talking about again and again in depth will definitely, right, we need to extend our time in that way, right? So just quote character, I briefly explained in this part as well, right, in too much detail that what is something the quote character, right? So every, right, so simple thing to understand, right? Even in a programming language, if you want to create any string, right, you, how you create it, you write it in this way, right? Either Shashank or simple other way, single quote, both works for the string type of data type, correct? So if this is the thing, but now just think from the CSV and these kind of uh, CSV kind of data formats, right? So those are delimited. So delimited means simply those delimiters, right, or the separators can be a part of a string as well, right? So normally, let's say if it was a name column, right, and a location column, right, and here let's say Shashank, and after that you would have written something, let's say Bangalore, comma India, right? If you would have written in this way, and you are trying to create a table, hive table on top of it, then obviously it will get crashed, because what will happen, there are only two columns you have defined in your create table, right? But your data in the actual CSV file is like way, this is a part of one value, but for hive it will be a confusing thing, because it can see one comma here and it can see one comma here. So this is the data incompatibility. This cannot be passed correctly based on the table schema. So for that one, what Hive will expect to this string to be enclosed, right, in the quoted manner, right? So that is the property which we have defined right here, the property which we have used the quote character, right, backward slash and this one single double quotes. So this double quote is a indication basically for this thing, right? What you say, the whole string part, right? Whole string, that this is the part which is basically a notification for the Hive engine that this incoming string value from the raw data, if delimiter and the delimiter or the separator character is a part of the value itself, so it shouldn't be used as a delimiter, it should be used as a string value, as simple as that to understand. And same for the escape character. So let's say whatever character you were using for the quote character, if that character also should be a part of the input string, that means it should be followed by this backward slash, so that this particular double quote can become a part of the string value itself. So I hope now this should be clear. So defining quote means we want to prevent our parsers to get confused with the delimiter, because delimiter can also be a part of the string itself, right? So how to deal with those things especially means those should be enclosed in particular double quotes, so that that can be tackled properly. So why we need escape character? Escape character is, oh God. So there are two things, guys, just focus, right, with the wordings. So there are two things. You have already used this double quote character. You have already used this double quote character for your quote property, right? For quote char property, you have used this character. Now, this double quote can also be a part of a string as well, right? Just understand all the worst cases which can happen with your string. This double quote can also be a part of a string. So how will you make it? You need a escape character for it, right? A special indication. And that special indication is this backward slash. That means if this double quotes needs to be a part of the string value itself, it has to be followed by a backward slash, so that my compiler can understand it. That is the main purpose of having the escape character. Cool. So I think now you have got the idea that how this whole thing is actually working. And now let me share this script and the data in the GitHub repo so that you guys can also follow it. Okay. And sometimes what can happen, since I'm using the lab environment, so most of these libraries are already imported in the Hive engine. But in case any of you finding a difficulty, right, that how this will be done, and these kind of parsing errors, let's say you are getting, and let's say this library is not present, so let me write a command. You need to import that package externally, and you need to add that package in your Hive terminal explicitly, right? So let me add first these scripts to your command, right? So first let me go out so that I can copy the data. So vim csv file, right? So this is the data you need to use, right? csv file.csv. So this is your data, right? And here is your command. Create table as CSV Saturday. So I'm just copying it. Make sure like you remove these cap signs and all, right? Because that is something which should not be used. Right. So this is there for you. And now what steps you need to follow if these kind of surveys libraries are not available for you. So what you can do, download Hive catalog jar file if survey libraries are not imported. And for that one, what you can Google search, simple Google search for this package. Just a second. Yeah, Google search for this package, Hive -h catalog core .0.14.0 right? Hive h catalog -core right -0.14.zar. Just do a Google search for this thing, right? And after that, what you can do, uh, in your Hive terminal, add jar file into your Hive shell. And remember, whenever you close your Hive shell or the terminal, all the properties, all imported files will be vanished. So whenever you are doing it, make sure you have done that. So add jar, let's say this file, right? You have stored it in your local. So for me, my local was basically /tmp hive class. So add jar, let's say /tmp hive class. Let me write it in that way so that you will get the idea. This needs to be run on a Hive terminal, and you need to add this jar. So once you execute this command, your jar will be added in the Hive terminal, and after that you can easily use these properties or these surveys, right? Moving forward, whatever, let's say even JSON and others we will be using. Now let me commit it. Cool, great. So Saturdays we have covered. Let's take a break of 5 minutes and we will resume again. And let me again share this GitHub repo link with you all. Means for everyone who haven't got it yet. So we will meet by 11:22 something. So this GitHub repo link will be available, right? Don't worry, it will be available in the resources link, right? So the jar file you have downloaded, right? Put it in your local file path, right? The way we are doing it, let's say /home, your name is, let's say Gokul Siddesh, whatever, right? /home /Siddesh, and then put the jar there and simply mention that path while adding jar from the Hive shell. All right, so can you guys hear me? We are back. Am I audible to everyone? Okay, cool. All right, so now we load command. Oh, yes, yes. Yeah, let me add that load command. Sorry about that. Load data local. Yes, 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 yes. This is Hive class 4, create table, and then it was loading the data. From local. Cool. I have added it and commit done. I'm going to share. Don't worry. I'm going to share the screen now. So see, we are pretty much sorted, and now I won't emphasize much on that how Saturday is actually working. You have got the pretty decent idea what we have done with CSV. I'll give you a quick example of the JSON as well. Let's say you have a JSON formatted data, right? Then how you can use a JSON Saturday and how it will be automatically passed for you. But before that, recall your previous class, right? Recall your previous class where I was or we discussed that let's say what will happen if we have the map, or not map, basically where we were discussing the array kind of data, and you can say this thing array kind of data, and the map kind of data. So how many of you remember that class and how we were doing that day? So if you guys remember that class, right? So we had a key value kind of pair in our raw data, and we had a, let's say, array kind of data in our thing, correct? Array sort of a string. We were using these kind of data types, right? External data types, right? In order to define it. And we had to mention few properties as well. Let's say what will be the separator for our collection, what will be the separator for our map values, right? So explicitly we had to mention those things so that our data could be passed successfully. But with the help of Surday's JSON Surday, that will be automatically taken care. We don't need to we don't need to define that, okay, what separator we need to use for the map type of fields, what separator we need to use for the array kind of fields, right? Those things we don't need to define. We can simply define our custom data types. We will use our Surday library specifically for the JSON, and everything will be taken care for us, right? So quickly, let me prepare our data set, right? So for that one, just a second. Vim and JSON file dot JSON, right? Quickly, I will write some dummy data into it, and how it will be whenever we talk about the JSON surveys or JSON related things, right? So how it will be expected? It will be expected like a one JSON object in one row, right? So first will be name, right? This is the JSON myth, and ID 1, and then skills will be, let's say, Hadoop comma Python, right? So this is our first row in the JSON data, right? So here, if you look at this raw data, this is a normal field, right? This is also a normal field, but here, this field, right, skills is basically the array values, right? So now this will be the interesting thing for a JSON to deal with, right? How to automatically pass these things and how to understand the data or how to understand JSON data itself, right? So that thing is will be taken care by the Hive engine when we will define the surveys. So now the second record which I will enter is, let's say, Sumit, ID is 2, and he knows Hadoop and Hive, right? And let's third one, and this guy knows Python and Airflow. Third, this is, let's say, Sean, correct? So this data set has been prepared, and now simply use it, copy it into the local temp Hive class, and this data is there. Open our Hive terminal. Use Hive class B1 Hive class B1 and use Hive class B1. There we will try to create a table with JSON survey, and that will be a simple. We don't need to define any sort of property because our even JSON data don't contain those sort of values which is quite nested or that kind of thing. But here the interesting fact is that we don't need to define any external property to deal with array kind of data. Let's say what will be the separator for our arrays, right? The data which is stored in the array list kind of thing and map kind of thing. Those things we don't need to define. Everything will be taken care by the JSON survey library itself. It will automatically understand this data and will parse it accordingly. So create table JSON table, and here name as a string, and then id comma id will be the int, and after that skills. So skills will be of array type. That thing we need to define for sure, but how it will be parsed, that will be taken care by the JSON itself, right? And here row format survey means whatever row will be displayed or computed, so that our object should be deserialized using this library, right? Row format survey org dot apache org.apache.hive.h catalog dot data dot JSON survey, right? So this is we have defined, and after that it will be stored as text file. Did I miss something? Let me rewrite it. We have written a wrong package name. Just a second. Create table JSON. Name ID array. It's not data survey 2 catalog do Hive, Apache, Apache, Hadoop.hive, org.apache.hadoop.hive.serde2 JSON serde. If not, then I will show that H catalog path, right? Maybe this JSON serde would have been missing from the imported one. So let's try one more time. If it works not, then I will download that jar, will show you that how it is being taken care. Not an issue. Next file. Cool. So it seems like this is not working. I also need to download that jar file for CSV. It was already there. So let me download that H catalog jar and I will add it. So where that is, this is the catalog, right? I will simply download it. Download jar file. This one I need to download. So this has been downloaded and I need to do a SCP. For that one, I need to copy it into my remote server. So how it will be done? Just a second, I'll show you how it is happening. So SCP downloads Hive catalog jar. And so this is the thing which I need to use. This is the user @ this is my server, right? And /tmp/hive class asking for password. I have pasted the password and that jar file has been copied. Cool. Let me add that jar file. So add jar /tmp file tmp/hive class, and the whole package name was this. So jar file has been added. Now if I do this thing again, create JSON table and name string, then the ID, then skills, then this one, and the package which was named as hcatalog JSON. So where that was one, org.apache.hive.hcatalog.data.json serde, right? Now stored as text file. And not validate. Now we have already added the jar file as well. Interesting. No worries. Let's figure it out. Not this one. Cannot validate the data JSON survey OpenX. Not this one. On trip survey to JSON, there are actually multiple packages, so that could be an issue. Hive catalog. ORG cannot validate survey. Let's see. Did he get a resolution for it? Still inputs? No. Let's check from the community itself. What could be the issue? The installer HTTP version is provided by. We have already downloaded this jar, but strange, it is not working. We have done it. org.apache.hive hcatalog.data.json survey. Revalidate. So row format survey org.apache.to. Okay. Got it. Text. org Apache Hive. org Apache Hive catalog.data. I think this is correct. Stored Hive catalog JSON survey. org Apache Hive catalog data JSON survey. It's wrong. Let me try again. It shouldn't happen. These are the commands which have been included, added, all those things, but pretty strange, not working at this moment. Now that can be tried, but this shouldn't be an issue. Like this quoting part, if it happens, my mind will be blown. org.apache.hive.h catalog.data.json survey. We have imported the package. We have added that part as well successfully. These resources, we can see it has been added, but let's try this thing. See, we are again getting this error. Come on. Cannot validate. No, that is, I have used the database as well. Apache. Let me check. Yeah, could be a case sensitive thing as well, but org.apache.hive, which catalog, JSON data set. This is also correct. I don't think so. Adding hive setting is all following error. And this is such a time waste thing. Row format, Saturday. Yeah, that has to be capital. I mean, this is super weird, super weird. This kills the time, right? Wait, why I can see a space here? This shouldn't be a space. Space is not there. This is fine. JSON said Apache hive.h catalog. I have used I the following error JSON said. If this not works, I can try another package as well. Let me try one more package because these libraries are mostly they are not an issue. Let me try with one more package. So anyways, this is also a learning. Working for me with that package. Try jar file from here. Okay. If it is, yeah, that is the part. I can try one more. So Hemant is saying this package is working for you. So could be the installation issue in the lab environment. Let me try one more jar file. You are saying download from Maven. Okay. Let's try from Maven once. Download the jar if that is the issue. Yeah, sometimes like those packages I didn't download it from Maven, so that could be an issue. Path or package, few things might be missing. So yeah, hcatalog core dot jar. Yeah, so let me check this one. So hive jar dot one. Okay, let me first, just a second, let me delete this thing. Let me download this jar, and again let me do a scp, but first let me remove it from the local. Just a second, right guys, I'll share my screen again and will tell you that why even it happened. So cd/tmp hive class rm hive catalog, right? So that has been deleted. Now let me do scp. Okay, where is the password? Password done. File has been copied. Let me start the hive. I will add the jar again. Use hive class b1 and create table, then name, not create table. First let me add the jar. Okay, so I have added the jar. Now let me create the table. I'm trying it at my end first, and then if seems working, then I will share this thing with you and will tell where to download. If not, then I will fix it right in my free time. We'll continue on other topic because you have already got the idea of Surdy. This is nothing, just a package import issues and all, nothing more than that. Sometimes those libraries might be older one and not maintained and not working with the current versions. So that could be the only issue. But again, let's give it a try. If it works, then this should be fine. Awesome, cool. It worked. Package imported. Let me share my screen and I will share that link as well from where you guys need to download it. Cool. You guys can see my screen again, right? So here now you can see I followed the same steps, and that could be the only issue of the dependency, right? And the jar which I downloaded from the link, it might not contain those packages, right? So that was the issue. So let me add this link from where you need to download, and you can see in this page, right? So this is the thing you need to download, right? Hive jar 0.4.jar. You might see other files as well, but make sure to match the exact file path name. So let me add this link in the GitHub repo. So download from the local. So Google search for this one. Download from this path, right? Cool. So this is done. Now we need to load the data. So load data local in path file (tmp hive class JSON file.json to table JSON table. Cool. So data has been loaded. Hive.cli print header equals to true, and let's perform a select star from JSON table. Cool. So we can see our headers and all these things and output. Now here you can see how easily this JSON Surday library has parsed this data, right? Where few that first of all, the raw data was completely in the JSON format, and within that there were few data sets which were, let's say, of array type and all. Although in the table definition we just mentioned this custom data types, but we didn't mention anything explicitly that what should be the separator for our collections and all those things. So now you can see with the help of these like libraries, these serialization, deserialization libraries, how you can deal with custom type of data, how that can be serialized and deserialized. Now you might be wondering whether this is actually working like an actual array type or just a string which has got printed here. So we can definitely check it. And for that one, we will be using same thing, right? To iterate over the array type of data types, we need to use the array name and in the square brackets indexes, right? And indexes in arrays start from 0, 1, 2, 3, something like that. So let's try to, so this is our skills variable, which, or you can say skills column, which represents the array type of data. So if I write only this thing, right? I just want to know the primary skill which different employee knows. So what I can do, select name comma skill 0 from JSON table, right? So let's see whether if it has been imported successfully as a proper array data type with the help of JSON surdays. So we will see the correct output, right? Only the primary skill, which is Hadoop, Airflow, should get printed, right? So we can see here name, and I didn't provided any alias name for skill 0. So that is why _C1 it is coming, but other values, Hadoop, Airflow, you can see this is getting printed here. So any doubt, any confusion for this one? Awesome. So I think what now from this one, what I'm expecting that at least Saturday part is something which is more clear to you. And this, if let's say there is any confusion, so when we will be giving you the assignments and the final task after completing the Hive module, there we will, these things will be included where you need to work on it, right? The last command only. So that the last command was pretty simple, right? Nothing. What I'm doing, the table, right? I had 3 columns: name, comma, ID, comma, skills. So select name, comma, the skills was something of array type, and so this is an array. So first value we can find on the 0th index, second value we can find on the first index, right? So what I did, I just wanted to pull out the first element in the array of each list. So that is why I mentioned skill and the element from the 0th index, right? Cool. So let me add this thing as well. First, let me go out and add that JSON data for you all. So Vim JSON file, ये रहा data, right? Add file, create a new file, JSON file.csv, and here is your data, and this is done. So let's say any of you finding difficulties with the jars, if let's say even you are not able to download or you didn't find the exact link, so let me upload the jar file here as well in the git repo. Let me upload the jar file, and same you can also download, right? So where it is, hive, this jar, let me upload it here. So now this jar file is also available in the git repo. You guys can get it. And again, I will put the, so let's say anything you have added from, you are doing it from the Hive terminal. So if you close it and restart it again, then your previously important packages will gone. So no need to remove package and all that thing, right? And in the Hive 4 class, I will add this thing. Yes, I'm adding it in this one. Not to worry about it. Let me add the command. So this is the create table command. Create JSON table. And load data into JSON. Cool. So finally, at least our Saturday part is done. And now I will move on to the few things which I wanted to show you all, right? So describe part is done. Okay. And our Saturday part is done. Let me mark it as a completed, right? Now, what I'm going to talk about basically, so first thing what you guys need to do, and for that one, I will share the command as well, correct? So in the GitHub repository, right, I will share, I have uploaded one data set, right? This is a pretty big, like in at least close to MBs and at least 90,000 records. And I downloaded this data so that we can play around it. I can show a few good things around it, that how it will be done. So this is the data set, right? Which is already present in the this thing, what you say, the GitHub repository, correct? So just this is the next task we are going to do, right? We will see few things, right, which I wanted to show you that how it works, correct? So download this data first. Download sales data. So this sales data is basically for the vehicles, right, in different cities of the US. So this is the data you can download. And again, this data basically will have the header row as well. So while creating and uploading the data into the CSV file, you need to make sure that you are skipping the first header row, correct? And after that, let me paste the commands, right? Create table commands I have already handy with me, so I can paste it so that it won't take much time for you guys to create this data, right? Create CSV table for sales data, right? So that is I have added in the git one. And once that is done, I'm not sharing anything as of now. I will share it. Now I will not write a load command by myself again. I want you guys to write all those things. Load load CSV data into above mentioned tables, right? After that, what you need to do, you need to create one ORC file, right? ORC file, and then copy data from this file to this ORC file, correct? So this is something I have committed, right, in the Hive class 4 txt, and now I'm sharing the screen. Is it visible now? Here you can see, right, I have attached something, the data set location. So first what you need to do, you need to create a CSV table, right? And these many columns are present in that data set. So your CSV table will be created. That will be an internal table. I haven't written the load command. You need to write the load command so that the data can be loaded in the CSV table. After that, what you need to do, earlier we saw that how Parquet file are being created. For that, we had to use the keyword stored as Parquet. Now this time what I have done, I have created one more table named as sales order data ORC, and this will be stored as ORC. So yesterday's class, if you remember how we were copying the data from one table to another table, we use command like from star insert overwrite into the sales order data ORC, and as select star. So those two commands I already talked about in the previous class, so you can refer that one. So with the help of that, you need to load the data from the CSV to this CSV table to this one, so that data can be moved into the Hive warehouse in the form of the ORC format, right? And after that, now I'm going to show you few things that like just the Hive commands, right? You guys had few concerns that or not concerns, basically questions, that how those multiple number of reducers work, how those will be created, right? All those type of questions you had. So in order to rectify that one, right, I will use this data set for your understanding, and will try to clarify all those things, how things happen under the hood in Hive. Right, so let me do this thing. I have already created a one database, use Hive class 4, right? And in that one, I already created these tables. Now you need to create all these things by your own, whatever steps I have mentioned, correct? So first, let me do this property hive dot cli dot print dot header equals to true, right? This is done. So first thing what I am going to show you that if you have not configured the number of reducers by your own, then by default, how many reducers will be spinned up by the Hive engine, and how you can provide the custom number of the reducers. So for that, I am going to run a very simple group by query, right? So group by query is nothing. This data set actually has one column named as sales, right? And one column named as year, year ID, or basically year. So few values for 2003, right? And let's say then 2004, and then 2004, 2005, 2005. So let's say in and there will be, let's say, quarter, right? So in quarter 1, quarter 2, quarter, let's say 4, quarter 5, quarter 6, quarter 7, right? So in this, let's say the sale happened 200 rupees, 500 rupees, 700 rupees, 100 rupees, and 300 rupees, and 200 rupees, right? So this is the data. Like you need to deep dive into the data. I have already uploaded it and understand it. So this is basically first row, which represents in quarter 1 in year 2003, this much was the sale. So what kind of query now I want to run? I want to run a simple group by query, and that query will look like this: select, right, year ID, comma, sum of sales, and that column will be named as total sales. Total sales from sales data. And what I want to do, I want to do a group by, right? I want to compute this data based on the year by basis. So year ID, correct? So this is the query I want to write. So final outcome will be what? One group will be created for year 2003, and the summation will be calculated of the sales column. So our end output will look like something this: 2003, 700, total sale, total 700, 2004, it is 700 plus 100, it will be 800, and for 2005 this will be 300, 200, which will be 500. So this is the dummy example I have given. So this is the type of query I'm going to run, and I will show you that by default what all things will happen, correct? So select year ID, comma, sum of sales as total sales from this table, year ID, sum sales as total sales, group by year ID, right? So let's run this query. Oh, column name is it is year ID, right? So let's execute this query, and I will show you on the screen how many number of let's say mappers and reducers are getting created, and then we will see few more things. Now this data is pretty much big, right? 90,000 records. That is why you can see it is taking a little bit of time. And here you can see the number of mappers has been created 1, and number of reducers which has been created, and that is equivalent to 1, right? Now the output is getting computed, and here you can see the total output. So for year, the total sale happened, and these values are after the decimal. So this one, this one, this one, correct? Now you have seen these things, and even in the day one, I talked about this thing that Hive, what it does behind the scene, it will simply convert our HQL queries into the map reduce code, right? So we can definitely get more and more parallelism. We can increase the number of reducers, right? So that the things can be computed fast. And if we want multi-part data in our output files, right? So that is how it can be done, correct? So this part is clear. Let me paste this query, right, in the, let me paste this query in the sheet, and after that, whatever I'm going to do, I will write it in this one as well. Right, so execute this query. So here only one map and one reduce task will get created, right? So this is done. Now if I come back here, so when even I was executing this query, Hive recommended few things to me, few suggestions, right? So just read these things carefully, these parameters of Hive. In order to set a constant number of reducers, we need to use this property. In order to limit the maximum number of reducers, like the maximum number of reducers which can go and which can be created by Hive, we can use this property. In order to change the average load for a reducer in bytes, right? So let's say we only 3 reducers were created, and what we want to do, we want to put less load on each reducer. Load means the number of records it is producing. So we can also limit that part. Let's say earlier by default, each reducer were processing 200 KB of the data. We can limit this thing by this property. What we will assign here, that per reducer, the number of bytes it should process, let's say somewhere 200 or something like that, so that the minimalistic load and minimalistic volume of data is going on to each reducers. So that is how you can play around these properties. But now, in order to show that how we can restrict the numbers of the reducers, so here this is a constant, right? Constant means we are fixing the number of reducers in our Hive, and whenever a new computation query we will fire, Hive will use these number of reducers in order to compute it, which we have defined here. So let us do that. What I will do, I will set this number to 3, and now I will fire the same query again, and we will see a difference this time. Right, so let it get computed again. Data is pretty big, so let's try out that when we will get the output. So here you can see number of mapper is equivalent to 1, and number of reducers, how many reducers have got created, that is equivalent to the 3, right? So let it get computed, and after that I will show one more thing which we discussed yesterday, that let's say if we are creating any table, so how many number of partitions will be written into the HDFS directory, which is eventually our warehouse. So this property is pretty much clear in the chat box, that how to deal with the custom number of reducers. Cool. So let me paste all these 3 property with a proper text, right? So that you can look into it and play around with these properties, try out those things, right, by your own. So that text I have added, and let me comment this part. That has been done. And now, cool. So what I will do now, I will use the same, let's say that command which we saw yesterday, how to take a backup of a table or create a duplicate table from another table, right? So what I'll be doing, I'll be doing the same thing. And what I will try to do, right? Create table sales order grouped ORC version 1, right? This is the table I'm going to create table, this one. It should also get stored as ORC. And what kind of data it will store, that I will mention in the query, right? So this group by data, this is the same thing, this aggregated data I want to store in this table, right? Correct. So this is the query I have written, and now let's run it. So this is executing, and what this query will do, so whatever output is getting generated by this particular query, it will use the same metadata, like only 2 columns, and this type of table will be created, right? And I will show the actual differences, right? What I want. So again, since we fix the number of reducers, so 3 reducers will be executing and they will compute the output, and that will be dumped for this particular table. So let it get computed. Cool. This is done. So a number of reducers were created. Now let me change this number again, right? I will set this property to again to something else, right? This time, let's say only 2 reducers, right? So I have overwritten this property, and I will use the same command, right? And what I will try to do, I will create another table, ORC table, with name same and the version 2, right? And I will execute this command. So this time, how many reducers got created? 2 reducers only, right? So let it complete, and then I will show you something in the HDFS path. HDFS path means the warehouse where Hive is storing this data, or Hive created 2 more tables, right? Grouped 1 and grouped 2 something, correct? So now let me do exit and Hadoop fs-ls. Let me use this path. Right. So if I go into our warehouse, Hive warehouse, right? So first thing which I want to show for the table 1, right? And that time the property which we actually used, right there, the custom property was grouped ORC. The custom property was the number of reducers were 3. So here what you can see, so this table which got created, it eventually has 3 parts in it, in its directory. So if you remember yesterday, I was explaining the same thing. So whenever you compute something over the cluster, right, in a map reduce way or a partition way, so the number of reducers which are computing and aggregated the things, every individual reducer will write its own output into the destination. And that is the same thing happened with us. So first time we used 3 number of reducers, we executed our group by query, and we created one table with the help of that. So that table will again eventually a Hive table. So whatever data will go, it will go into the HDFS, right? So for that query, the target destination was the HDFS location. Since the number of reducers were equivalent to 3, that is why 3 parts got created here. Now if I do this thing, right, V2. So in V2, how many parts you can see? You can see 2 parts, because what happened? What we did, we overwritten the number of reducers, right? And that number of reducer was equivalent to 2. So in the second attempt, when we created that table, so that is the thing happened. Only 2 reducers were there, and only those 2 reducers wrote the output in the HDFS directory. So this is clear, pretty much sorted. Multi-part, how it is going to happen and how you can play around all these things in the Hive terminal, these properties, pretty much clear. So whatever this is written, right, this is a multi-part, right? This will hold your actual data. So this is one file name given to your actual data. Some part will be stored in this one, some part will be stored in this one, some part will be stored in this one, right? So whatever is this number is written, that is basically file name given to your that specific chunk, right? The multi-parts. So reducer is definitely doing a computation, right? In the first class, we talked about this thing. The mapper is something which will do the intermediate computation. At the end, whatever, let's say, aggregations we are doing, typical joins, let's say the reduce, the group by, the reduce by, right? Where we want to club things together and sum it together. The actual thing is done by the reducer here itself, right? Right. So I will so I will basically paste these commands which I have written in the Git again. So, right. So let me start the editing part, and I will add all those things, correct? So first what I did, I used the reducer which were equivalent to number 3, right? So for that, what I did, change number of reduces to 3. This thing we did, and after that we created one table, right? So after creating the table, check the number of files in HDFS location, correct? After that, what we will do, we will change number of reducers to 2, and then we will create another table and we will repeat the same thing. Cool. Understood? Yes. So that is something which happened, which was done, like multiple parts were created, smaller chunks, right? And this command, right, don't get confused. Simple, which I wrote here, right? Create table, and the table name is stored as ORC as. So whatever will be the output of the statement which I have written after the as, let's say select year ID, sum, and all these things. So it will generate the output where it will have only two columns, the year ID, right? The year ID and the sum of the sales, right? So those two will be treated as an input column for the table, which we have mentioned in the create table part, and the data or the table will be created in the Hive, or you can say as a Hive managed table. So yesterday I explained this thing, right? Yesterday I explained this part where I showed you one command that how to create a backup table and the you can say duplicate table. So you can reiterate on the previous lecture. There I explained that command in depth. So shall we move on to the next thing? And yes, I definitely need to move. Now again, I will show you one more important thing, which is important from the interview perspective. In the interviews, most of the time that question has been asked, right? So let me talk about that one. Cool. So let me start the Hive again. Cool. So use Hive class 4. Correct. So what we are going to do, we are going to see a difference between order by and sort by keywords in the Hive, right? What happens if we run a order by and what happens if we run a sort by, right? So first, let me execute those two commands. I will show you the outputs, and after that, right, I will explain the difference. So what I'm going to do, I'm just going to select the year ID, select year ID, right, from that table sales order data ORC. Select year ID from sales order data ORC. Order by. So this order by command basically is pretty much equivalent to the SQL. Whenever we want to, let's say, display our output in ascending order or the descending order of any column, in that case we will be using this order by keyword, and whatever column we will mention after this order by keyword, so when our output will be displayed, it will be sorted in the ascending or descending order based on that particular column, right? So that's how it will be. But even before that, let me set that terminal print header true, right? Just a second. So set hive.cli.print.header equals to true. And now say select year ID from sales order data ORC order by year ID descending. This keyword, like by default, if you will use any column with the order by clause, so by default it will be, your output will be sorted in the ascending order. But let's say in case you want to sort it in the descending, you can mention this keyword after the column name, so your output will be sorted in the descending order. So let me run this one, right, and I will show you. Order by, but even before that, right, let me do one thing. Right, let me do one thing. Let me set the number of reducers, then it will make more sense to show you this command, right? So the command for setting what's map reduce dot job, map reduce dot job dot reduces, map reduce dot job dot reduces equals to 3, right? So we have set this property, and now I'm going to run this order by command. And let's see the output. So did you notice one thing? Number of mappers, number of reducers. I want you to notice this thing because that is the main thing to talk about the difference part here, right? So I know this output is pretty much big. I will quickly go to up. Okay, that is already lost. But that is why I wanted to show you, right? The number of reducers and the number of mappers and the number of reducers which actually got created. Those were like equivalent to 1, although explicitly we mentioned the number of reducers should be equals to 3, but still when we use the order by command, right? So what happened? Order by command basically used only one reducer, correct? Now let me, and here you can see this output is pretty much sorted in the descending, right? Where here we cannot see anything jumbled, right? So at the end, obviously 2003 we have, and before that 2004, and on top of we had a 2005. So whole output is not displayed because of the screen constraint, but that is how the values have been printed over the screen in the descending order: 2005, then 2004, then 2003. Now let's run this command, same command, and this time I need to use this sort by. So sort by also does the same thing. It also sorts the output based on the column which you have provided after that one. So now let me run this thing. And again, you need to observe the thing, right? In the order by, it was only one mapper, one reducer, although we explicitly use that property like number of reducers should be 3. But in the sort by command, it is different. You can see number of mappers is equivalent to 1 and number of reducers is equivalent to 3. And I will show you the output as well. Correct? So this is the output which has been, which is getting printed. So here you can see 2003, right? And then 2004, some data 2004, and after that some data 2005 in the descending order. And then this is the interesting point to see, right? 2005 and then 2003 started, right? So this is the main part to understand here. This section, if I start from this part 2005 and if I go till the end, it is pretty much sorted in the way we wanted. But after this point onwards, right, it again started as a 2003, and if I go up we will see 2004, and if we go little bit more up we will see 2005, and again 2003 started, right? So this might look confusing, but I'll tell you what is the reason here. If you have observed, you would have got your answers clearly, right? If not, then let me explain this thing. Yes, most of you are definitely correct. This happened because of the number of 3 reducers, right? But how it is happening, and what is the actual difference between the order by and sort by? So let me explain it, right? So let's say this was your data, right? This was your data where let's say something is written, right? So this is year, and this is, let's say, sales. So this is, let's say, 2003 and 100, 2005, then 200, 2005, again 400, 2005, then 100, 2003, let's say 700, 2004, 900, right? Then again 2003, 200, 2003, 100, 2004, 600, and 2004, 500, right? So now when we use the order by command, so the concept of order by, right? The concept of order by is arrange. Order by is basically arrange data globally, right? Arrange data globally means now if we are using the order by, so doesn't matter how big your data is, right? Everything, every record and all that data will come to only one reducer. This whole data will come to one reducer. And if everything is at one reducer, right, and then you try to rearrange it based on the year column, so you will get the global output, right? So multiple entries for 2005, at least three records I have included, then 2004, then 2004, then 2004, 2003, 2003, and 2003, right? So this is the command over the Hive terminal. You saw, although explicitly we mentioned the number of reducers equals to 3, but still it was using only one reducer to compute the things, right? Now let's come back to this part, the sort by, how sort by thing actually working, right? So in the sort by, the definition of sort by is basically local sorting, right? So this was our data, right? And explicitly we mentioned three reducers. So R1, R2, and R3. So what was happening when we did and we applied this sort by on the year ID? So let's say this was one section, right, which went to reducer R1. This was another section, right, which went to reducer R2, and this was another section which actually went to reducer R3. So every individual reducer has its own chunk of data to process. So that sort by command will apply the sorting within that chunk, not globally, right? So let's say R1 had mixed number of records for 2005, 2004, and 2003. So the data which will, let's say, produced by R1 was 2005, 2004, and 2003. So on the screen, right, which I was displaying, so this was the output which was produced by reducer R1, and reducer R2 was also processing few records related to 2005, few related to 2004, and few related to 2003. So 2005, 2004, and 2003. This is why it was printed over the screen and the output of the reducer R2. Now 2005, 2004, and 2003. So that was the main reason. And this is actual difference between the sort by and the order by command as well. Did you get it? Clear? I will paste these commands as well in the GitHub. No, so this is not the idea. We shouldn't keep the reducer count to equivalent to 2, sorry, will it shouldn't be uh, 1, like the reducer count shouldn't be 1, because in that way we will not be able to achieve the parallelism of the computation. And this is now the question for you all, right? This is the question I have added in the challenge as well. Now you guys need to explain me, if we only keep one reducer, then what could be the most horrible disadvantages of that one? You just guys need to brainstorm it. I can discuss it in next Q&A classes, but this is a task for you to think from your basics perspective, right? Uh, whatever we have taught you so far, the fundamentals of distributed computation, storages, and all these things, right? Come up with a thought that what could be the disadvantages of it. And I'm telling you, these kind of practical questions you will be getting from the interviewer. Let's say you explain, okay, the difference between order by and sort by. The next question from the interviewer will be the same one. Okay, now tell me the disadvantages of using order by, or tell me the disadvantages of using the sort by, right? So just brainstorm it a little bit, do your own research, and before that, like if even before googling anything, just uh, try to put your own thought, right, based on your knowledge of the distributed computation, what you think can go wrong if we use only one reducer. Cool, so great. Let's take a 5 minutes of break and we will again restart. Cool. Let's take a 10 minutes of break. So we will meet at 12:50. And today I will reduce the time for the diode session, and I will focus more on to the things which we need to cover, so that at least from the challenge perspective, which the challenge I will give you. So few questions will be related to that part as well. And that is why I want to cover it, so that you guys can explore in the challenge, right? So let's meet at 12:50. All right. So am I audible, guys? Awesome. Cool. So now things, right? Importantly, three things are remaining. One is the UDF, second is partitioning bucketing, and third is emphasizing more on the joins and all these things, correct? So now the next thing which I'm gonna focus, and very much important, like since it is very much important from the interviews perspective and all, right? You can say the even core, the whole core of your Hive interviews will run around it. That is Hive, that is partitioning and bucketing. So I will start from the partitioning and bucketing. We'll try to explain it in today's class, and the next one I will keep it for the those smaller topics, the UDF and the joining part, right? The I will explain multiple joins and the optimized joins in Hive, and that would be a wrap of our Hive tutorials as well, right? But today it is more important to discuss from the partitioning and bucketing, so that uh, like you can perform well in the challenge part, because few things are included in the challenge related to the partitioning and bucketing. And since this is a very important concept as well, so I will start with that one, correct? Sounds good. Yes, yes, yes. बहुत ही बढ़िया. Cool. So let me start with that one, partitioning and bucketing. So let me okay. So the partitioning part. Cool. So partitioning here, I will ask you few logical questions first, right? Answer those logical questions, and then I will explain the partitioning, right? So when we talk about the distributed computation, or let's say storing the huge volume of the data, terabyte and the petabytes of data, and let's say you are a data analyst or a business analyst who want to query that data, and you have a very minimalistic requirement. Although 1 TB data is stored, what you want to query a specific set of data, right? Using the some filtration logic and all. So now let's say you fire that query. So if your data is not optimally stored, what will happen in that case? Right? You have 1 TB of data, but you want to do processing on very small chunk of data based on your requirement. You know few rules that you can apply to partition that data, and those rules will be always constant. But what could be the major impact and the bottleneck in our processing? Yes, you guys are almost there. I can see couple of answers, more time, the slow processing, the entire data scan, and all these things. So yes, you are definitely almost there, and this is the logical thing. So whenever we have, let's say, 1 terabyte of data and 2 terabyte, this amount of data which is stored in, let's say, HDFS or these persistent storages, and we are using these kind of data warehousing services like Hive, right, and others. So what will happen in that case? Even if you need a very smaller chunk of data, right, a smaller chunk of data to be queried and to perform some aggregations, what will happen? The whole table scan will happen. 1 TB of data, because Hive engine doesn't know. Let's say you applied filter where department equals to software engineering, right? So in your 1 TB of data, you don't know at which particular location, right, your records related to software engineering department are stored, correct? You don't know any information. So ultimately, by at any cost, you need to do that full table scan to pull those records where your filter condition is getting matched, right? So this table, full table scan, is something which will like give a poor performance while performing Hive queries, right? It will even take, let's say, more than 2 hours, 3 hours, 4 hours, right, to scan all those things. And you are saying like the but columnar solve this issue. Columnar file format will solve the issue of aggregation, like taking a sum, taking a group by. But when it comes to the filtration, right? Filtration means you need to match the values one by one, right? So let's say this is one record, right? This is record number 1, right? And here the value is, let's say, Shashank, right? And IT department. This is record number 2, which is stored in memory, Rahul, right? And QA. This is record number 3, right? Let's say Anil and IT department. So if you have applied the filter, right? If you have applied the filter for this one, department should be IT, let's say. So it doesn't matter if you have, let's say, like 1 million records in your table, still you need to go on to each record because you need to check whether that record belongs to the IT department or not. Am I correct? Is it understood? Right? So doesn't matter, like uh because your data is not something, it is not stored in that way so that you can quickly figure out, okay, yes, this is the whole data chunk which belongs to the IT department and I can start my query, right? Because this data records are stored randomly in the HDFS and your memory. So doesn't matter how small your data is and how big your data is, you need to scan each and every individual row to match your filter condition. And that is the part where you will get the bad performance. And in order to resolve this, right, in the big data, this general concept of partitioning came into the picture. So partitioning is not just restricted to the Hive, it has become a general concept of the big data processing. There will be lots of there are multiple not lots of multiple databases as well, which one of them we have included in our curriculum, Cassandra, right? So that also stores data in the partitioning manner. We have other data warehousing services like Snowflake, Redshift. They also stores the data in the partitioned way. And because the partition is something which can improve the performance a lot, and that is the main reason it has become the general concept of the big data processing. So make sure whenever you appear in the design interviews as well, the data pipeline design interviews for the data engineering, there just remember all these concepts. So let's say your interviewer asks you that you have this amount of data in the source location and we are getting a bad like runtime for the query execution. How will you optimize it? So this is also one of the optimization factors. So remember these keywords so that you can use it in your design rounds as well. Correct? Got it? Cool. So now I will explain the partitioning part and how it eventually looks like basically in Hive and how it the partition data gets stored in the HDFS location, right? So for that one, what I will do, I will take a name of a data set again, let's say employee data set, to just give you the clarity, right? Employee data set, it will have name, salary, and location of that employee, where, like, in which country, basically, not location. Let me rename it. It should be the country, right? I will write 5-6 records. So keep on suggesting me names. Shashank, salary 1 INR, country India, right? Okay, name Abdul 1000, and let's say London. London is not a country. Right? Let's say UK. Right? And Shashank, let's say Amit, 500, and let's say again India. And Rahul, now I am sending Rahul to China. And Surbi, 800, and USA, right? Kapil Sharma, 900, and again let's say USA. And Hulk, Hulk is in Russia. Cool. So this is the simple like name. I just wanted to make it a little bit fun, right? So name, salary, country, correct? So these are the employees, right? Their salaries, and they are working in different countries, right? Now this is a very smaller data set I have created, and just imagine, right, a great company, right, having millions of employees, right, working from different geographic locations, right? So how big that data set would be, obviously in GBs and in the terabytes, correct? So now what the idea of partitioning came into picture, that let's try to leverage this data and just try to pick those kind of columns which are being used most frequently for filtering the data, right? So this is also one of the thought process, right? Lots of times you will be asked the interview questions that which column should be used, which column should be used for partitioning. Now, with your intuition and with your common sense, just apply your common sense and tell me this question, right? What kind of column will you try to use for partitioning the data? Here you can see in this data set, many folks are saying the country. Just let's take an example of any other random data set. So from the business perspective and from the optimization perspective, what would be your general idea to pick those sort of columns? Just try to think, right? Correct. I'm getting good answers here. So see, the idea in order to divide the data, or like somebody kind of data set, which column ideally we should use for partitioning our data, right? So there will be multiple thought process behind it, and I am going to write that one. So first thought process should filter the data, right? So the columns used to filter the data frequently. Are you guys able to hear me? Am I audible? Is it clear? Okay, cool. So I can repeat. I will repeat. So while choosing the any particular column for the partitioning, there should be a thought process, right? It shouldn't be random, right? Always, right? You need to justify, and you need to understand what kind of analytical operations you will be doing in that data set. Then you will try to understand that, okay, what could be the best fit column for the partitioning part, right? So first criteria should be column, any like column simple or combination of columns which are being used most frequently for the data filtration. This is one criteria, right? Second criteria, always avoid, right? This is the most important thing, and I will ask one follow-up question on that one. Always, I'm talking about in terms of the hive perspectives, right? Not hives only, in general as well. Always avoid primary key type of columns for partitioning. Cool. Now, this is a question for you. I'll move ahead after this one. Now, tell me why sometimes we should avoid using the primary key for the partitioning part. Because it's unique, lots of partition. Wonderful, wonderful. You guys are like, kya hi bataun, maze, right? So lots of you are giving the exact answer, right? The lots of partitions will be created, right? Let's assume you have 1 million of records in your file, and each record is unique. Like your primary key, let's say you are using employee ID, right? Employee ID is your primary key, and you have 1 million unique records. And by any chance, you used employee ID, which was primary key, and you used it as a partition key as well. So can you imagine how many number of partitions will get created in your HDFS? 1 million partitions will get created. That is super bad. This is not something we want to achieve, right? We don't want like these many number of partitions, because this will be a hell lot of headache for the hive. Like hive will not even able to process properly, right? So that is the thing. We always try to avoid the primary key columns, right, for the partitioning part. And this is one of the most pet questions of the interviews in the hive, that if I ask you to use primary key as a partition column, will you use it or not, right? So this is how you need to justify, correct? So first criteria, columns, those are being used frequently for the you can say filtration. Second, always avoid primary key. So the better candidate will be, right, where less uniqueness, right? Less uniqueness means any column which is not like with any column, let's say, which you can say eventually repeated multiple times or used multiple times. Yes, like country, repeated multiple times or used, correct? So in that way, what happens? See, the main idea of partitioning is to divide our 1 terabyte of table into smaller chunks, and those smaller chunks should be small enough so that they can contain at least some amount of data which is relevant for the processing, right? It shouldn't be unique like throughout the problem statements, correct? So less uniqueness, repeated multiple times or used, correct? So this is the reasons which I mentioned here. This is the first one, right? This is the second one, how you can choose. This is the third one, correct? So these should be the your criterias. First of all, whenever someone's give you the case studies, just try to think from the perspective, right? If you are someone who want to query this amount of huge data, right, what kind of challenges you can see and how you can optimize it. So now I will again come back to our example. Now everybody in a single voice can predict which column we should use here. for the our partitioning part, right? And that is something also which should be very, very relevant. I saw a few folks were saying salary column can be used, but let me know in the comment section, do you think any relevance of making salary as a partition column? Do you think, right, most of the time you will be searching the employees based on their salaries? Okay, how many of getting 1000, how many of getting 2000? That does it something which adds any kind of business value if you use salary as a partition? Country is the most relevant. Correct, right? So now you have got the idea that how this thing is going to happen. And now let me show you that how this thing will be happen when we actually create the partition tables, right? Let's say we have created a Hive table. I will show you practically like what kind of commands we need to write, how all those things will be happening. But whenever you create any Hive table with partitions. So normally, like normal table, how if normal internal Hive table, what would be its path? Normal internal Hive table, how its path will look like in the Hive warehouse. It will be something like users, Hive warehouse, correct? Then slash DB name, and then slash our table name, correct? This is how our normal table gets stored in the Hive warehouse. Right now, when we talk about the any table with the partition, right? Any table which is partition on any column, few columns, right? How its storage will look like in the HDFS. So this will look like something this. Multiple partition, like multiple folders with the name of the partition will get created, right? So let's say you have 6 distinct. I'll go back to this one. How many distinct countries we have in this column? One country is India, UK, China, USA, and Russia, right? We have in total 5 distinct countries. So how many 5 distinct folders will get created in that HDFS, right? 5 distinct folders will get created. So users, Hive, warehouse, DB name, then table name. And now after that, we have used country as a partition column. So what will happen? It will be written something like this. Country equals to India, right? This kind of folder will get created. Similarly, this will be a whole path. Country USA. Similarly, country China. Similarly, country Russia. Similarly, UK. This is understood that how when we will partition, we will create partition for our Hive table. So how this data will look like in the backend and how it will get stored in the HDFS. This is clear, right? Are you guys able to hear me properly? I can see few comments like your class is getting ended automatically. Like, is there any technical issue at your end? No, right? Okay, okay, cool. All right, so this partitioning part is clear, right? Partitioning part, that how it is completely happening and how this data will look like, right? So first, let me complete the whole theoretical aspect of it, then I will show you things practically as well, correct? So this is the first part. Now, in Hive, there are two types of partitioning. First is the static partitioning. And second is the dynamic partitioning. Cool. So now let's try to understand how this static partitioning works and how this dynamic partitioning works, right? So in this case, what will happen? Let's say, let's talk about the static one. So static one, what happens in the static partitioning? We know that what, just a second, right? So in static partition, what happens? We know in which partition data will get loaded. So in a static partitioning of Hive, what will happen? We will have the information of the partition beforehand, right? And we can manipulate on those partitions by ourselves, right? We will have that information in which partition we need to store the data, right? So that is static, completely static, where we are not letting Hive to decide that how many partitions are going to be created. Eventually, we are deciding that which partition will be created and how that data will get stored in it. And eventually, while loading the data, we can define that specific partition in the load command, that yes, this is the partition where data should go, right? So that is how the static partitioning work. Means everything is static, everything is hard coded. We know that what partition will get created, we already know what will be the value of the partition, and we can even handle this thing like loading the data into the specific partition, right? These things will be wherever, like in any kind of use case, if these things are known and we are operating in this way, that means we are using the static partitioning, right? And now let's talk about the dynamic partitioning, right? So any confusion and doubt for the static one, right? Obviously I will explain it via practical examples, will show you that how this looks like, but at least from the theoretical understanding perspective, static partitioning, all good with that? So static partitioning, where everything will be known, right? That means what partition is there and in which partition we are going to load the data, right? So here, since we can see this data, right? Here we can eventually see this data, right? Since it is a small enough, we can see it, and we can even create partitions manually, right? That is completely for us, right? We can create that one. But just imagine if this is a 1 million record, right? And in the country column, you don't know how many distinct values are there. So if you don't have that kind of information, will you be able to create partitions by your own, and will you be able to load the data into any specific partition by your own? No, right? So if your data is that big enough, where whatever column you are using for the partitioning, you don't know how many distinct values it contains. In that case, you cannot create these partitions by your own. You cannot create these things by your own, right? You cannot do it. And that is the point where dynamic partitioning come into the picture. So let's say you want to load any data in your Hive tables where you have used a particular column as a partition column, but you don't know how many distinct values will be there. So that means you are doing a dynamic partitioning. Dynamic partitioning, what means? Hive will use that partition column and will try to find all the distinct values which are present in that column, and will create a one partition for each distinct value. And that is how the dynamic partitioning work. Clear the definition part, how this dynamic part will work, the dynamic partitioning? Hive will scan the partition column and will create partition in HDFS for each distinct value, right? So see, this part is this data set you can see, right? That is why I am saying you are able to see this data. That is why you can decide, okay, India is there, China is there, USA is there. Let me create a partition for India. Let me create a partition for China, and I will operate on it. But again, let's assume a very, very huge amount of data, 1 million, 2 million, 3 million. That whole data you cannot see. You cannot even know how many distinct values will be there until unless you query it, right? So just imagine those use cases where you cannot see the data and you want to use any particular column and you don't have any idea how many distinct values are there, right? So what you will try to do, you will let Hive to decide that, hey, I want you to do the dynamic partitioning on this input data. And Hive, what it will do, it will scan that column which we have mentioned for the partition. It will pick all the distinct values present in that column, and for each distinct value, it will create those many number of partitions in the HDFS. Is it clear? Is still any doubt for the dynamic one? So dynamic, again, I'm saying it will be decided by Hive itself, that the column is something, that column we will provide in the create table. We will let Hive know that, hey, this is the column I want to use for the partitioning, but I don't know that how many partitions should be created. So it's your responsibility now, figure out all those distinct values and create partitions accordingly. Whereas in the static partitioning, we know the partition column and we know the partitioning value as well. And we can do those things manually, right? Even loading data into specific partitioning and all those things can be done with the static partitioning. So the difference is clear? Yes, the practical part, once I will show you those things from practically, right, over the terminal, then it will be much more clear. Right? Now, one simple and logical question again, and that is the interview question as well. Just answer that one, and then I will move on to the main practical part, right? So, question, and this is an interview question as well, between dynamic and static partitioning, which one perform slow? Just based on your common sense and whatever theory we have discussed, try to imagine this thing, which one will be slow performing. And it would be great if you can put a justification for that one as well. Why any partitioning strategy will be slow? I can see mixed answer, static. Some of you are saying static will be slow. Some of you are saying dynamic will be slow. And I can see the reason for the dynamic. So yes, the folks who have said the dynamic, right? Dynamic is something which will perform slow, right? For the aspect, because when you create a table which is partition and you load data into it, then Hive has to go with the entire data set in order to figure out how many unique values are present there, right? And that would be the time where it will be a sort of a performance issue, at least that time when you are uploading the data, right? Because Hive needs to figure out how many partition it needs to be created, right? Once that part is done, so after that querying and everything will be pretty much similar. Doesn't matter if you do it via static partitioning or dynamic partitioning. Whereas in the static partitioning, it will be fast performing because we know the partition column. Obviously, we also know the partition value, and we also know in which partition to load the data, and we also know in which partition to pull the data. Everything is known in the static. So that is why it is or it will not take that much time in compared to the dynamic. But both have their own like pros and cons. Dynamic is something which will be really helpful if you don't know the distinct values and how many number of partitions will get created. Static is something which can be beneficial mostly where you have the smaller data sets and you want to partitioning it, because most of the time you will be knowing all those partition values as well. Got it? Now the difference is clear and you have noted down these interview questions as well. And I can bet, right, on paper anything, these interview questions you will face definitely if your interviewer is asking anything related to Hive. These are the pet questions, right? 1000% they will ask these questions. All right, so let's move on to the now practical part, right? All right, so let me create this data set there, right? Cool, do I exit, and the same data set which I was talking about, right? I will use it, right? I will create it quickly so that we can see this thing, right? So BIM employee data dot CSV. So first column is, let's say, the employee ID 100, Shashank 5000, India, right? Or wait, by the way, we can use our sales data as well, right? Why there is no need to create, because let me show the sales data and it has good amount of value there as well, right? So let me show you that what can be used from that one. So this is the sales data, right, which I given you. So there you can see, correct, these many number of our columns, and here we can see this country one as well, right? So this is definitely a good candidate, and we will use this one, and we have a good data set as well. I just want to see Australia, France, Italy, Japan, US, Australia, Spain. Cool. That should be used. That we have the data set. So let me simply start the Hive. Yes. So here year wise or country wise. So your point is definitely correct. I think this is a good point from Naveen. I can see in the chat box. So if I go into this data set, right, let me show you. And there are multiple candidates. Then that is why I am saying multiple times it will depend on your kind of queries, business queries, right? So I will show that example as well, that how the it can be done on the year wise as well. First, let me show it for one partition column, and then I will show that how partitions can be created for multiple columns. But yeah, that is something, right? It can be used, right, based on the use cases, what you are trying to do, what kind of queries, what type of queries you are trying to create, right? That is how it will be done. I will explain that multiple part as well, right? So not to worry about that one. Correct. So here we can see the country, and this year ID, right? You can see multiple duplicates for it and less uniqueness for the year as well. Correct. And we have the country as well. Correct. So first let's try with country, and then I will create one more partition table which will use country and year both. Then I will explain how this data looks like there. Cool. Just a second. I am starting with it. Okay. So let us start with the first static partitioning, right? So what is going to happen here? We will first create a table which will be a partition table, and after that what we will be doing, yeah, so use Hive class. And guys, for this one, please be attentive, right? This is something very crucial concepts and very important to understand. So please don't miss anything. Again, I repeat. So set hive.cli dot print dot header, right, equals to true. So let's first show tables, and I have already loaded the data in this CSV table, right? So select, it is stored in CSV and it is stored in ORC. So let me query this one. So select, let's say country, comma, year ID, just to show you that data is there or not, from this table, and limit 10, right? Oh, I missed that limit part. Right, so this is there, right? We can see country, year, and all these things, and there are other attributes as well. Correct. So since that data is there, correct, now how we can actually do it? So we have this table, and now we want to create the partitions table where our data will get stored. So first, what we are trying to do here, we are trying to do the static partitioning. And before that, let me talk about our property, right, which is our property, right, for you can say which is a property for the partitioning and the table scanning part, correct? So that property is basically something which restricts the whole map reduce part, right, or the full table scanning, correct? So there is one property, although by default this will be always set to true. So hive dot map red dot mode, right, equals to strict, right? So by default this is the property which will always be set to strict by default. And what this property actually means, this property means, let's say you have enabled this property in hive, and by mistake itself, let's say after setting this property, right, what you are doing, you are doing a select star right from this ORC table, right? If you are doing this thing, and let's say this is a 1 TB of file. So when we will enable that property which I was writing, what will happen? Somehow the hive will throw you the error if your data is in, let's say, GBs and terabytes, because the full table is going to happen. So those are the things somehow can be enabled in order to prevent the full table scanning, if you are pretty much sure about the static partitioning and all. But I was just giving you the idea. So by default that property is always set to true, and I will put it in the GitHub repo link that how to enable this one. But now let me create a table which will be a static partition, right? So there what I am going to do, I will not include those many number of columns or those number of the data sets. So if I go here, what I will pick, let's say order number, right? So the definition will be create table sales data static part, right? Sales data static part, and then I will put this value, it will be int, right? And I will use the quantity ordered, right? This column, this will be also int, and then it will have the sales column. Let's say the sales column, right? It will be float. And then after that year ID, right, it will be int, and only these many number of columns I want to keep it into the table, right? Now what I want to do here, this keyword I need to use, right? Anytime if we want to create our table as a partition table, while creating this table we need to mention this keyword. So partition by, right, and which column we will be using, we will be using this country column. So the column which is a part of our partition by keyword, that cannot be part of this internal create table statement. It has, or it should always be written on this one. You shouldn't include into this thing, right? So that is how it should be, right? Country has been created. Oh, it is not partition by, it is partition by. Sorry, the syntax mistake. So quantity ordered. Let me just a second. Create table. Order number. Quantity ordered. sales, year ID, and then it should be partitioned by. Syntax was correct. So partitioned by, right? So this table has been created. Let's try to run a describe formatted command and see its properties once. So describe formatted, correct? So here we can see this is the table we have created, and here you can see the column names, and here you can see the partition information. Partition information, the column which has been used for the partitioning, correct? This information we have got it. Now our data was already loaded in our table which was known as the ORC, right? So now I'm going to show you the command that how statically we are creating partition, right? We are not letting our Hive to decide that which distinct value you should use for the partitioning part, right? So just carefully watch the command which I am going to write now. So insert overwrite table, and table we have this one, right? So insert overwrite table, in which partition we want to load the data, right? So here in this data, right, let's say this data was stored in the original table, and original table was the sales order underscore ORC, where I have already uploaded this data, right? Now I have created one partition table, and in that partition table I want to only load the data for those records where country was equals to USA, right? So partition, that means I am statically in this command, I will mention that which partition and by which value it should get created. So country, right? Sales data static part country, and in which country partition I want to write the data, USA. So now you can figure out, right? Here, every single information I am providing, right? I created a static partition table, but while inserting and loading the data into it, I am telling the Hive that, hey, if this type of partition, right? Let's say country equals to USA kind of partition is not created in the HDFS, then Hive will create it. And whatever data I am pulling from other table with the help of filter, I will be dumping that data into that one, the country, correct? So now let's do that. Insert override table, and this partition I have already talked about. And in this partition, which or what type of data will go, that data we are pulling from our original table, which was the data which we already loaded in the sales order ORC table. So select, and this is the right 1, 2, 3, 4. These columns we also want to get populated, right, in this table which we have created for the static one. So obviously I need to bring these columns as well from that original table from which I want to load the data. So order number, first was the order number, then quantity ordered, quantity ordered, quantity ordered, then sales, then year ID, and from which table I already uploaded our data into this table. So I want to just filter out data from this table which belongs to USA, and I want to dump that filtered data which was for USA into a partition table which is statically partitioned, right? And I want to upload that data into that specific USA related partition, correct? So from this table, and I need to apply a condition, right? So let's say I miss this where clause condition. Here I have mentioned I want my data to be present in the USA partition. So ultimately it presents that the data which I am going to store in this partition or in this directory, that will belong to the USA. So I need to filter out that data, right, from the original table as well, which should be exactly mapped to those records where value of the country is equivalent to the USA. So that is why where country equals to USA. Just let me cross verify the value was USA or not. Yes, it is, right? Now let's run it. So this job has started, and after that we will go to the HDFS location and we'll try to see that how many partition has been created. Cool. So looks like something okay we have seen here. So feels like this has been created, right? So let me log in onto the screen again, and I will show you the main data into the HDFS location, how it now looks like. Cool. So let's run this command, hadoop fs-ls/user. I think this command, this path has been printed. So let me just copy it from this thing, right? I will show you. Things have already been created, but I want to show you practically. And at least I am pretty sure this in the Hive, people enjoy this part most, the partitioning, bucketing, playing around it, and the whole concept of it. This is pretty amazing, I would say, right? So if I do ls on this table which we have created, right, this path is basically our Hive warehouse path, and ultimately it is HDFS. And if I run it, hit enter, so I will show you what directory has been created. So you can see country equals to USA folder, which I was explaining here, that how data will look like into the HDFS folder. Now you might be wondering why all these partitions are not created. USA, China, Russia, UK. Why only this one? Just explain this thing to me in the chat box quickly, and it will tell me, yes, all the concept of static at least related are clear to you. It's static, right? So you guys have got the good idea about the static partitioning, how we did it. Although while creating this table, right, we didn't mention any such keyword, right? If you check this table creation, we didn't mention anything specifically, let's say partition by static, partition by something. We generally created, this is a partition table. It will work for dynamic, it will work for the static as well, right? But the thing which is most important to understand, that how we are loading the data in the static partition table, right? And that is the most important thing to understand here. And what is that one? This command which we have written, insert one, right? So in this command, I have mentioned, okay, country column I'm using for partition, and specifically I am mentioning which partition should be created, correct? So just let me know in the chat box quickly that is it clear or not. Then dynamic is very easy, very simple to understand. Awesome, right? So let me paste these commands as well, and the data, right, which we have talked about, it is there, and I have written down those steps as well in the table, right? First you need to load that data in CSV, and then you need to create that ORC table which I am using in my commands. So don't get confused. If you will follow those exact steps, nothing will be missed and you will be able to execute every single command, right? So let me paste this one into the GitHub repo. Cool. Just a second. Here, create table command for partition table, and here static for static, right? This is the command. Now load data in static partition. Now similarly, that will be your task as well. Here I created only one static partition. You need to create multiples as well. And before that, set this property. Set this property if doing static partition. By default, it is there, but still, let's add it so that you don't miss it any particular point of time. That property is set hive dot map red dot mode equals to strict. Cool. So it is merged now. So very quickly, we will see the great example of the dynamic partitioning. So before starting with the dynamic partitioning, we also need to enable one property, right? Then we will be able to do the dynamic partitioning, and that property is set hive dot execution. That means exec dynamic dot partition dot mode equals to non-strict. And this strict, non-strict, I already explained, because this will be something, if it is set to strict, that means you will not be able to do the dynamic partitioning. Hive will not allow you to do the full table scan. So that is why we need to enable this property first. Set hive execution dynamic partition dot mode equals to non-strict, and then we will be able to do the dynamic partitioning, right? So let's set this property, and let's create one more table, right? That will be, the definition will be completely same, right? Nothing changed on that part. So I will just change the table name. So it will be dynamic part. Dynamic part, and then this one, and first column will be order number, and then quantity ordered, and after that the year ID, no, after that sales, and then year ID. Cool. And this will be partitioned by country string again, right? So this is another table we have created for our dynamic partitioning. And now let's focus on the command which we will be writing to load the data in a dynamic partition table, and see the differences as well, right? So here, first of all, I will remove this where clause. So removing this where clause, what does it mean? That I am pulling the whole data set. I am pulling all the records from this source table, right? I am not filtering any specific section from it. And in this part, right, insert override table, right, partition by, I will simply mention the partition column. I will not specify any partition value as well. So this is the first difference you need to mention. We are not filtering any specific data set, and even while creating the partition, I am not mentioning in which partition our data should go, right? So this is the major difference. You need to understand how to load the data in dynamically partition table. Dynamic, right? And let's execute it. Column number types are different. Table in clause has 5 columns, but every query has 4 columns. Table because column number types, this shouldn't happen. We have already enabled the properties, but let's debug this part as well, that why we are getting this issue. I'm just wondering, there shouldn't be any kind of, what you say, there shouldn't be any kind of garbage, but even doesn't matter if it is the garbage one is still right, it will create a partition for the garbage, but still let's try to check something onto the country part. So country is pretty much sorted. Just want to check if I have missed something or not. I have enabled the property, that is also done. Canada, Australia, all these things, but still let me quickly check what is happening. Cannot insert into large table column. This is the thing, why it is happening. Partition country US. Hive is not Oracle, and Hive partition columns are managed as metadata. They are not included in the data files. Instead, they are used as a subdirectory name. So your partition table just have 2 real columns. Did I miss something? Partition country, I have done it. Partition country I have used. Oh, stupid. Sorry guys, sorry for my stupidity. I didn't bring the country column. So how would even this Hive table will know that which column to be used? Sorry for that mistake. So since in the static partitioning, I was doing this filtration, right? So that data was going completely into it. But now this time Hive needs to figure out how many distinct values are in the, you can say, country column. So obviously in this select statement, I need to bring that country column as well. And this will be passed as an input to this command, right? And the whole data will be included here, correct? So now let's look at this data set, right? The dynamic part which has been created. So I'm just hoping everything was fine and it has been created. So let's go there and check it out. What has happened? Hope all the partitions are created. Don't want anything dynamic. Don't want anything to be missed. Awesome. Wow, such a cool output. You guys can see, right? These dynamic partitions. Does it look like a super happy output? Awesome, right? So whatever we wanted to get here, so this is exactly whatever I explained on this page, exactly the replica of the output, right? You can see here, correct? So let me paste this part as well so that you can see and figure out all those kind of differences. So let me paste these things in the get repo, and after that I will quickly show you one example for, let's say, using multiple columns in the especially for the dynamic cases. Same thing will be for a static one, but I'll quickly show you for the dynamic, if you are using 2 columns for the partition, how it will work, and how that data will look like. And since yeah, we are almost on time, so partitioning, the bucketing, UDF, and the one more thing, the joins, I will be covering in the next class, because already 4 hours, I don't want to bombard with so many things in one single day. Already it is too much, I know, to practice and do the challenge as well. But I hope at least this class you would have enjoyed a lot, because partitioning and these things are the concept I personally like a lot in the Hive, right? So set this property for dynamic partitioning. Yeah, I'll be giving the challenge, don't worry. I will share the sheet, what is the challenge and everything I will explain. Correct. So this is the thing, and let's check it out, the data part. Load data in dynamically partition table. Cool. So the dynamic partitioning part is also sorted. And now I will quickly show you that part, right? Let's say try to create a table which is using the country, and after that it is using the year as well, right? So how, and in this case sequence will also matter, right? So let's say imagine those countries and all those things, right? So the table, let's say we created, let's say create dynamic table we created, right? Few columns were there, and after that partition by. Now in this case what we want to do here, partition by, let's say country, right? And the year ID. So in the HDFS, how these partitions now will look like. So this HDFS path, right, till this point. After that, country equals to USA will be done, right? And within that one more directory will get created, year ID 2005. And let's say for even this country, right, USA, multiple records for year ID 2005, multiple records for 2004. So everything will be captured in multiple directories, right? 2004, similarly these things, right? So that is how this multi-level of partitioning will be working. But even guys, we did the partitioning, but we didn't use it for our purpose. And let's do that purpose part. So since we partitioned our data, now at least if group by query and all these things, our output should be faster if we are able to use the filter conditions based on this specific country part, right? So let's say we only want to filter out the data for the Australia and just do a quick group by on it, correct? So let's do that and try that part. So select what we want to do. We included the year ID as well, right? Year ID comma sum of sales as total sale from our table will be this one, the dynamic part table. From this table we want to query and the condition. And whenever you have partitioned your table, right, so obviously we need to use these columns in where clause, right? Else there is no use of these partitioning and all if we are not using these columns in the where clauses, right? That is why these were actually designed. So country equals to Australia, and yeah, we are doing group by on year ID. So within the data set which has been partitioned for Australia, there what we want to do, we want to group by things on year ID and want to take a sum of it, right? So let's run it. Right? So we can see this time pretty much quick, 4.64 seconds cumulative and all. And earlier when we were doing it on the whole table data set, I do remember it was going somewhere between 12 to 13 seconds, correct? And now you can see the output is also just with respect to the data set, which was meant for the Australia, right? So this thing we have also seen. Now let's quickly try to do the partitioning. Create one more partition, multi, you can say dynamic partitioning. So dynamic multi-level partitioning, right? So we want to create something like this. So first column, we will include order number, and then after that quantity ordered, and then after that sales, and since year ID and country will be a part of partition, that is why they will not be a part of original sales table, right? So country string year ID int, right? So that is how we have created our partition by part, right? Now we will use the same data set which we used basically for our dynamic partitioning, and the command was this one, right? So here we are almost bringing all our columns which are eventually needed for our partitioning. So the sequence we used here for our partitioning, right? So the same sequence we need to provide in this part, right? Partition first will be the country, second will be the year ID, correct? And we need to just change this table name, multi-level partitioning, and let's run it. Awesome. Looks like thing has been created, and let's try to check our beautiful output. If it is there, maze. Dynamic multi-level part. What has happened? Country equals to 2003. Looks like something has happened. I can see this is created. Wait, something I'm missing. Directory file does not exist. It is saying, wait, okay. Country 2004, how it has become 2004? Country ID, I have given country sequence perfectly. Okay, looks like this statement, right? Okay, got it. Let me do it in that way. New what has happened, multi-partitioning v1. Quickly, let me create it. So ordered number, and then it will be quantity ordered, and then it will be sales. So this same sequence, because if you see the mistake, right, which looks like is a mistake. So I'm bringing year ID and then the country. So that sequence, right, has been hodgepodged. So I need to change that one. That is a missing part. So quantity sales has been done, partition by year ID, that is done. Cool. So let me copy the name, and let's get back to the insert command. So this sequence I need to change, because this output will be also read in the sequence. So country and then year ID it should be. So after this one, we shouldn't face this problem. V1. Cool, let's do it. So order number, quantity order, sales, country, year ID, every sequence has become perfectly fine. Let's run it and check our output. It does not exist. Let's run it now. Try to see this thing. Multi-level Philippines. Okay, let me check. Okay, this level of partitioning has been created, and let's try to look the data into this one, each partition, how this data looks like. Within this partition, cool. We can see the data, right? So see, once you will run this part, right, this HDFS, so you will see whatever is printed here. You will not see that entire path like multi-level partitioning on this line itself. You need to go into that partition as well. You need to do the ls into that partition, and then you can see, right, within Australia, year ID 2005 and year ID 2004 and 2003, all those things had been created. Got it? Got it? Like completely understood that how this multi-level partitioning is also working. And also the main important part to follow the mistake we did, the partitioning, the sequencing part is something which was pretty much important, right? So let me paste these commands for you all. And this is a sub partition, right? Like why you are getting confused? This is the sub partition. If I'm saying that the multi-level partitioning, it is a sub partitioning. First partition, whatever the country is a primary partition, and under that multiple sub parts are getting created, and that's how you can even increase this hierarchy. Even under the year partition, you want to include something, just add it in a sequence. That's it. So let me add it, and that would be the end of our class today, and remaining time I will dedicate for the Q&A. But yeah, first I will explain the assignment part, multi-level partition. And this is the thing, the data. load data in multi-level partitions. Cool. Woohoo! Awesome. Clap, clap, clap. 217. Wow. Right, long class, I know, but see, we need to move little bit fast, else you guys will blame me that why didn't you cover the course. So I'm also making sure we move little bit fast and with precision, not like above the head thing. Whatever I'm explaining, it is going beyond your head. That is why I'm focusing more on the practical side. So let me in the chat box how is the thing is going so far for you. At least from the Hive classes, pretty much understood. I'm hoping that it is not now a black box for you, right? You know the great concepts of it and all those things. Awesome, awesome. Cool. So now first quickly, let me talk about the assignment part, right? And that will be the challenge. And as discussed for the challenge part tomorrow, the main idea is you guys need to push yourself, like focus on your learnings, right? Rather than the competing and winning is the secondary thing here. But you are fighting for your learnings. That is the main idea, and that is why this challenge is there for you. There will be 1-2 assignment and you need to complete it at your pace. It is not like it will depend on the time submission, how quickly somebody submits this one. It is completely depend on how best you are able to do it. And again, we want to push other folks as well. So I want you to showcase your learnings as of now you have done on your social media, and just make this challenge pretty viral, right? Wherever you want to post, LinkedIn obviously would be the preference. You can tag me, Sudhanshu, iNeuron, whoever you want to, and just notify other people that yes, you are engaging into this challenge to push yourself. So let's do that. And as I said, the top 3 winners will be getting the Amazon Alexa, and I'll be bringing these kind of amazing challenges for every module. Cool. So the hashtag you can use something like this, Hive challenge with Shashank, and that would be pretty amazing, right? We need to make it viral so that other folks can also understand how we are learning at iNeuron together, like practical project-based learnings, not just restricting ourselves towards the theoretical aspects, right? So you will be doing it, right? Cool. So let me first upload that thing, right, which I want you to so there will be eventually 3 things you need to complete, right? And I will also attach a link, right, where you need to submit those things, correct? So I will attach a Google form link. So let me first copy this part, right? And I will make sure those things will be available to you in your, let's say, today's class resources. So this is the Google form link where you need to submit your assignments, right? And what are those submits and assignments? Let me upload it in the GitHub itself, right? Let me upload it. So upload file. So first challenge. Yes. So I am uploading one PDF that will be your first challenge, and what it consists, this particular file will consist more than 60 Hive interview questions, and you and whatever at least things we have covered so far, most of the things you will be able to answer by your own, right? So I'm not sharing my screen as of now. I'm just giving you this file name, which you can find right in the GitHub repo. So I have uploaded that PDF and I have committed it, right? So let me give you that link as well, that PDF link. This is your first task, right? Your first thing. So this is right. Now let me upload another one, which I want you to do that. And I just want your pure honesty, guys, right? Because it is all about, not again I'm repeating winning, it is all about your learnings. So I want your honesty, whatever you are doing, just whatever we have taught so far. If you want to watch previous recordings, please do that, but make sure you are doing it with full honesty. And one more assignment I have uploaded, and all those things I will make sure available on your dashboards, right? So that you can pull it from there. So one more I have uploaded, this will be your second task, right? Assignment 3.txt, right? This will be your second task. So whatever is left, let's say bucketing and all these things, will be definitely covered on the next class, right? Now let me share one more with you all. Just a second. And that will be pretty much scenario based. So let me copy it. Challenge. Add file, create new file. Hive. I will rename those files, right? You will just Hive challenge task 3. Right. So this is one more, and I will quickly update task 1, task 2, task 3, right? I will update those file names which I have given. So let me rename it there quickly. So Hive challenge, let me rename it. Let me see if that can be done. This file pro to file. Yeah. Anyways, at least I have mentioned these three files, right? And I will make sure that those are available. But let me know first uh, in the chat box, right? All three things which I shared, these three tasks, is it visible to you in the GitHub repo or not? All three things. Right. So I am expecting, so the way you need to submit your files, right? Mention it, say, let's say your name, right? And let's say batch 1, name batch 1, and solution Hive task 1, solution Hive task 2, solution Hive task 3. So create 3 files and put it in one folder and create a zip file of it, and then upload it on that Google form link, which I talked about, right? So, and yes, we want to make it viral, this challenge, and definitely you will be featured on iNeuron social medias as well when you will win this Amazon Alexa prize. So deadline is, again, at least I'm expecting it before next class. And again, I'm saying it is not like the speed will matter. It is like the accuracy and your solution, which will matter a lot to win this challenge. Understood? So we will have next 24 minutes. I know it is a tiring day today. We covered a lot of things. So that is why we will dedicate minimalistic time for Q&A. And the next class we will be doing, we will do more and more Q&A part, right? I will adjust that time. So that Google link I shared with you, all right. And I will make sure this information is shared with you all over the mail as well, right? So again, I am posting the Google form link in the chat box, right? Multiple times. I am pasting it, and let me know if you guys are able to see this Google form link and it is accessible and everything, right? So just copy it. So Instagram is not, I'm not expecting, just even LinkedIn is something which will be suffice, right? And again, quickly, I will paste the links for the assignments, right? So you can consider anything as assignment 1. So this is your Control A Z, just a second, let me put it at one place, right? So this is assignment 1, right? This is your, let's say, assignment 2, right? Just a second. Task 1, task 2, task 3. Cool. Again, I am pasting it multiple times. I hope you will be able to access it. Again, I said for the submission part, right? Don't get confused. I have shared one Google form link as well. There you need to upload your assignments. I have shared already. I have shared one Google form link. You need to use that one to submit your assignment. I repeat, and I'm pasting it again. And from this point now, there shouldn't be any confusion. And now I'm opening the chats for the Q&A part. So raise your hands and go one by one for the Q&A. Cool. So first question from Henry. Hey, Henry.
Can you hear me, sir?
Yep, I can.
Okay, I wanted to remind you about the task I sent to you, and I could not see your.
I will try to look into it. I'm definitely not getting time from my busy schedules, like my office and all. But whenever I'll get a time, right, or let's say we can connect over one-to-one at later point of time, we will discuss it. Uh, just give me some time, right? I'm quite occupied, Henry.
Oh, because they gave me a deadline, so that's why. But no problem. I was supposed to have submitted last week, but I asked for more time.
Mm-hmm. Right. No worries. Okay, so I saw one comment, right, in the Google form, right? Guys, you will not find any upload link. So what you can do, whatever solution you have created, right? Whatever solution you have created, make sure to create your GitHub repo and upload your solution into the GitHub repo, like Hive solution 1, Hive solution 2, Hive solution 3, and in the Google form, right? What you need to do, you need to share your GitHub link. Got it? Clear? That how to submit the things, how to do the submission part in the GitHub. You need to create your repo. That's what 3 assignment, right? The first assignment or the first task is those interview questions, right? So 3 in total, 3 assignments you need to work on. And first, let me know, right? The submission part is clear, how to submit that assignment. You need to upload your solutions on your GitHub and share that GitHub repo link in the Google form. In the Google form, you will see one link. Right? Cool. Let's go for the next one. Srinath.
Yeah. Hi. Actually, the last two steps that you did for a static load for loading the static, table as well as dynamic partition, right? Static partition, dynamic partition. In those, you have selected only. You have put made three columns there, right? And then later you are selecting five columns. Like it will it by default take the country and the year because you had it as partition columns.
No, can you repeat? Are you asking for the dynamic or the
Yeah, you can take as an example dynamic. If you see the
mhm,
statement, create statement, right? You had
right?
three columns there, and then you said partition by country and year.
Okay, so yeah, that part I explained. So whatever column you will be picking for the partitioning, right? Those won't be the part of your actual data set, which will be written to the HDFS, right? Those
Okay.
will be identified with the directory naming convention, right? Let's say country equals to USA. So when you will be applying it as a filter, right, that will definitely work. But the original data which will go right into the partition table, that will be which is mainly included in the create statements. But even still in the partition by, we are providing those names and data types so that hive can easily figure out that what column needs to be used and what is its actual data type for the partitioning.
So for example, if I have to do a select statement on that table, select star, it will
Mhm.
only give three columns, right? It won't give the country and year.
Yes, yes, yes.
Okay, okay, got it. Thanks.
Cool. Next one, Yogesh.
Hello. Yeah, sort of just like two doubts. First one is like when you were creating the partition thing, I noticed that you are taking the sales data from the GitHub, and then that was that ORC, right? So then you are taking CSV into ORC, or like how was it? Like
No, not CSV into ORC, right? So yesterday, even not yesterday, but if you remember in the GitHub repo, right, I uploaded few commands, or even yesterday, right, when we were looking at the Parquet data, right, when we were
yes.
discussing about the serialization, deserialization, right? So that Parquet part, so how we were loading the data, right? Directly when we tried to load the CSV part into the Parquet sort of table, we were getting the error, right?
Yes,
The
yes,
load
right.
was successful, but when we were querying it, the
It
deserialization
was like
error was happening. Correct.
yes.
So what we did, there were two ways I discussed. Either your source data is, if it is completely in Parquet, so if you create the Parquet table and load data, everything will work fine. If not, let's say your original data was loaded somewhere in the Hive table as a CSV, so simply we can use that command, right? Create
Stored as
a
Parquet.
table, and yes, from another table, and the original table, sorry, the table where we want to dump the data, that will be Parquet, sort of like stored as Parquet. So same thing, right? Even yesterday I told this part, repeat this exercise for the ORC. So when I loaded this data, I have included these steps in today's class as well, right? If you will open that GitHub link for class 4.txt, so I have included all these things. Sales data is in the CSV format. First, you will create a CSV table, load that data there, create another table which will be of ORC type, right? And move data from CSV table to the ORC one. And then start doing all other operations which we talked about.
Okay, and another thing is like I noticed you have Mac, so like actually that FileZilla thing, right, for downloading the table, like I'm not able to do it. So can you just show it to me if you don't mind? The
I
CSV
am actually using
table.
MacBook, so I don't have that FileZilla because it is not needed there, right? So if you are facing that issue, can you tell me that one? What is this? Else you can connect with the tech team. They will get it resolved for you.
So I also have MacBook. So if I have to just put in the terminal, can you tell me that is it that copy thing? Because how can I load the CSV on the
Cloudera VM.
local system? Yeah.
Yeah. So for that one, you can simply use the SCP command.
SCP. Okay.
Yeah, SCP
Maybe
command. Try the SCP command and it will be done.
sure, I'll look into it. And sort of that // you were mentioning, right? When you said like for
Quote character and
separator is,
escape character.
yeah, yes. Separator is very easy. If we are having comma, we separate it. That is a separator. Then it's the quote. If, for example, Sashank, comma, double quotes, DE and 100. So Hive is confused, which is like which to take. So we are using quote. And then the third part was the escape, where you are using double slash. So that second slash was when the double quote is exiting, there we will use second slash, or like
No.
it was.
So see the purpose of double slash. So in the computer science world, right, few things are right pretty much treated as a special character, right? If anybody knows how we define the new line character, this one, right, in computer science, how we define the tab this way, correct?
Yes.
So similarly, now let's say this backslash is somehow also a special character. So when I was talking about the escape character, right, and escape character, those all definition I had to mention in the string. So first I use this double quote part, and within that I used this thing, double quote, and then one more double for backslash, and then one more quoting part, right? So using this double slash and using this double slash means what will happen, whatever character is written just after this first backward slash will be treated as a string, not as a special character. So let's say for the escape character I would have mentioned this thing, right? Then this escape part would not work because backslash will be treated as a special character. So I want this thing, right, to be treated as a string part. That is why I added one more forward slash, so that any string which is coming like this, let's say Shashank, right, and then it will be a forward backward slash, then double quotes, then DE, right, then one more backward slash, then quotes, and then this one. So this part is basically will be reflected in this way, and we had to add this one more backslash. So this is treated as a string, not as a special character. So the outcome of this string which is written here based on this parsing logic will be Shashank
Double quotes D.
Yes, Shashank double quote D. Got it?
Got it. And this was when you were putting that, but when you were doing some other functions, you were not giving this output, this quote and exclaim. So is it always required to give?
Not. So it will depend on how your data looks like. So the data which I prepared, so there it means it was included. The delimiter was part of a string as well, right? There wasn't any string where I need to make the double quote as a part of a string, but just it can be added, right? It can be added as a property. But normally previous classes, whatever CSV file we were working, it was pretty simple, right? One single string, normal comma, normal values. So that is why we were not like initializing these properties. But whenever we have to deal with a special type of data formats, right, we need that kind of serialization, deserialization, and along with the properties, so that correct data parsing can happen.
Okay, thank you. Thanks.
Yeah, cool. Next, Rakesh.
Yeah, hi Shashank.
Hey.
Yeah, can we update the data which is loaded into the Hive table?
Update the data. Okay, updating the data is, so Hive and these warehousing services are not meant for those kind of operation. Let's say the way you do it in MySQL and other things like the frequent CRUD operations, delete something, update something, write something, right? Hive and these services are not meant for it. The main purpose of having these warehousing services is to write once and read many times and do the aggregations and all. That is why batch processing and the batch load part we keep on doing into the Hive, right? So updation is something which is pretty much hard to do and manage in the Hive because indexing cannot be applied, right? So even if you, let's say, have a 1 TB of the data and you want to update one single record, let's say where name is equivalent to Shashank, correct? It will take like many hours for Hive to do that kind of updation, because it needs to scan whole data set and need to point out to that particular location and write that part. But again, since it is not something where data is, let's say, continuously getting stored the way it is stored in the transactional databases, so that is why Hive is not meant for updates.
So last time you have shared the data about COVID, right? In that we have world meter data, and in that case, in that data, there is a column like total deaths.
Okay.
So when we load it into Hive, it is showing the null values there. What if we want zeros instead of null values?
So zero instead of away, what is zero instead of nulls, right?
Yes.
Right. Cool. So in that case, you can figure out, right? You can check this, right? This would be something which you can check in the create table, right? The way we do it in the transactional databases, let's say default 0 or something, right? You can just explore this part, right? Whether that can be done in the Hive or not, the default values or not. But mostly how it is done, let's say in the analytical world, if we see these kind of nulls, right? Or that kind of data set, right? Mostly query can be fired, let's say, for sure, but mostly this data is, let's say, read by the pandas library or the Spark data frames. So they have that capability to deal with the nulls, right? You can specify those default type of values there.
Okay, that's it. Thank you.
Yeah. Cool. Next, Shri. Hey, Shri, please go ahead quickly.
Hi, yeah. I think if others are over, this I think is my first class. So most of the concepts are a bit hard for me because I understand. So I thought it was supposed to be a completely new class. So I need your help to go through it, or should you? Because I understand that you already went to the assignment.
No, so I can totally get it. So not to worry about anything, Shri. So whatever previous classes we have done for the Hive and for the Hadoop basics and fundamentals, all those recordings are available for you, right? Just go through with that and you will be able to catch it up, right? Even a week of time, you will be able to catch it up. Not a hard thing. And this assignment part is something you can pick once you are pretty much comfortable with the previous classes and whatever I have taught so far in the Hive one. Not to worry about anything. We are not that far in our batch and we are not that far in our course. We have started it, right? So that is how it is.
Okay, where exactly you do this Hive?
So this is the lab environment where I'm writing this command, and this lab environment is getting set up for the learners as well. So just in a week and 1.5 weeks, right, you will see this lab environment in your dashboard, and you can also see the same interface where you will be writing these kind of queries without installing anything, right? Everything will be pre-installed for you. You just need to execute the things. So it is in progress.
Else, can I set it up on my environment?
Sorry?
Else, can I set it up on my environment?
Yes, you can set it up at your environment, and those setup related things have already been discussed in the previous class. The Cloudera environment. Yeah.
So only Hadoop Hive is only taught, or any others are taught?
Hadoop fundamentals, Hadoop basics were also covered in the before Hive.
All right. Thank you. This can let them know.
Yeah, cool. Next from Shripad, please go ahead quickly.
Hi Srikanth. So related to today's practical session, so I had the doubt in the Saturday CSV. So I tried to follow the class and try to do the hands-on. So in the CSV, so I was able to create a table, but the data was not. I am unable to populate it in the CSV table. I followed the commands whatever you shared in the GitHub. So I was thinking whether any permission issue was there, but I tried to do the chmod 777 also, but I'm unable to get that what you say, the data inside the table.
So you are not able to create that file like using vim command and all. You are not able to do that.
No, I created the Vim. I created, so I copied the. I think you have shared the data set also, right? CSV data. You have shared it in the GitHub. So I copied that and pasted it in the Vim and stored it. I'm able to query the data set actually. Means in the Linux, I'm able to query it. I'm able
Okay.
to get the data also. But when I try to load local command is there, right? So when I
Okay.
try to use that in the created table,
So,
I'm only getting the schema, but not the data. So
so
that's
it
not.
is that file you are talking about, it is in your home location, or you have first loaded in the temp location as well?
That is in the data you are talking about. So data is in
File,
the
yes, that file.
local. It is in local, the local only, temp local location only.
Temp local location.
Yeah.
Okay. And is it throwing any permission related issue, or like file does not exist? What is happening?
No. It is saying okay only. So when I try to do the load command, it is displaying that some data some is
And
copied one.
did you check the warehouse path as well, where the file has been copied or not, or anything?
Yes, yeah, I have like located the. See, I have checked the warehouse path also. I used cat command for
Mm-hmm.
that and seen the data whether it is
So data
displayed.
was there or not?
It was there. It was coming.
But when you were querying it, you were not getting the output.
Exactly. When I'm after load, right? After loading the data into the table, right? When I try to do select star on that table, right? So I'm
Okay.
unable to get the data. Only schema it is coming.
All right, interesting. So I think that is something which might need little bit of digging. So can you do this thing, Shripad? Just share your commands, right? Once with me over the mail, and I will look into it. That what might have gone wrong. Just share it with me over the
Okay.
mail.
Okay. So this is one doubt. So one apart from that, related to the sort by and order by, today you said, right? So that is one is using the sort by is using the local this one sort and order by uses global sort. So because of that, reducer's output will be changed. So I wanted to know from this experiment, can we conclude that sort by shouldn't be used in the big data like Hive or anything, Spark in such way? So we should only rely on order by for sorting.
No. That is not true, right? So see, order by, that's what I gave you as a question. You like need to figure out when to use the sort by, when to use the order by. I can answer it, but since I have given it as a question to other folks as well, to figure it out by your own ones, right? I know the answer, and in with your intuition and with your logical and common sense, you can also think that what could go wrong if you only go with the order by, because it will be just one reducer for you, right? So that global sorting and everything, it is not something which will be entertained for that huge amount of the data, right? So whenever we talk about the data, right, that is pretty much good for the displaying part. If you are doing a data sampling, you can display it over the screen in pretty much sorted and formatted order, correct? But whenever we talk about the data processing part, right, the whole uh, complete processing of the data and all, then yes, if you want to let's say, I'll take an example of that thing, local, you can say uh, uh, local as in local sorting if you want, correct? In that case, you will go ahead with the sort by, because every reducer will take a part into the computation, right? If you are not going ahead with that one and simple order by, so your machine will also run out of memory, because what will happen, let's say, where in with the node where your reducer is running, right, and you have one, let's say, even not 1 TB, let's say 100 GB of data, and your node is just having a capacity of 50 or 60 GB, right? So in the case of the order by, everything is going into one single reducer for that global processing, right? So in that case, you will be running out of memory. Your job it even will not get compute. So that global ordering is something which is pretty much recommended for the smaller data sets. But rest of the things, it should be like it should be locally, because in each single reducer, right, you will be doing that kind of aggregation, and for that one, if you want that data to be in pretty much ordered way, so that will be done in that particular reducer itself for that piece of the data.
Okay. So one more last doubt. So like what Rakesh told, I just wanted to add one point. So what if like if we wanted to change the data, can we temporarily pull the data into some pandas or something, and we can update it so that it will be reflected again in the Hive, right? So supposing what he said, if we wanted to change the null values, suppose I can take one query, one data, and store it in one data frame or in like Hive table or anything, and I can just update that with the syntax, and I can again write it right back into the same path so that it will be overwritten. So the values will be changed. So is that easy to way to change the?
Yeah, I mean, if you can, let's say, pull it with any kind of distributed application, right? Even if you, let's say, run or create that Python script, right, using pandas in your local machine, right, and running it and pulling the data, right, for that huge amount of the volume, probably it is not going to work, right? You need that distributed sort of environment. For that, you can write a Spark application. Within that, you can use the pandas data frame, get it computed, populate the values, and then use that output as a new modified CSV data, and then work on it, like create Hive table on top of it.
Okay. Oh, thanks.
Yeah, cool. So guys, today I will just take questions till 3 p.m. Right, and after that, like, we'll do it on the next class, right? Whatever doubts are remaining. So next, quickly, Ganesh. Let's be quick on that part. Hey, Ganesh.
Hi, Shashank.
Hey, yeah.
I have a couple of questions related to map reduce. When we are setting the number of reducers, we can set, right? How can we decide maximum number of reducers?
So that property I have already mentioned in that Git repo, right? I showed you three properties. One, to fix the constant number of reducers. First, to let Hive handle that how many maximum it should create. And second, even to optimize the load on the reducer. So those three properties
If you
I have
don't mind,
already mentioned.
if you don't mind, can you please repeat how it can decide maximum number of reducers?
So there will be a property, right? That is a property which I have already pasted in the GitHub repo, right? The sheet I have created. Just go through with that one. I already explained all these three properties where you can deal with the dynamic number of map and reducers tasks.
Okay, and second thing is when we have done that group by query, right? At the time of doing reducers, initially we have given 3 reducers, correct? At that time, it has taken the total time, it has taken 54 seconds. And next time we have run the same query with the 2 reducers, it has taken 34 seconds like that. Because if you're using more number of reducers, the time has to come down, right?
So more number of reducers, see here, this kind of optimization you will see when you mostly work on the large scale of the data set. Even, right, this data set we had the order one, right? Not a pretty big one, right? To get computer and the kind of cluster we are using. So the more number of reducers, sometimes, let's say for the smaller data sets, we are unnecessarily increasing the number of reducers. So that will be a more time, right? It is not necessary that that reducer will actually compute something, right? If it will be required, right, then it will do it. So let's say just we created one CSV file only having 3 records, and unnecessarily forcefully I'm setting this property, let's say 10 reducers. So do you think, is it necessary, like those 10 reducers, how can even those distribute that tiny part of the record? Right? So it will be dependent, right? That so the properties I was setting up, I wanted to give you the idea that how these things are actually manipulated. But that kind of optimization, right? Let's say if we have 100 GB of data and we are doing it with the only 2 reducers, and if we are doing it with the 5 reducers, then you will see the great impact, right? Not with these tiny number of like records which we are processing. It is just to give you the ideas.
Okay, that's all.
Yeah.
Thank you, sir.
Cool. Next, Mansi, quickly go ahead, please.
Hi, Shashank.
Hey.
I have 3 doubts. I wanted to ask you, where is this reducer actually like situated? Is it in that app master or in the data node? Like where?
In the data node, there will be containers, right, which will get created, and within those containers, these reducers functions will be running.
Okay, so the data from all the mappers will go to these particular reducers.
The actual computation happens on the slave nodes, or we can say the data nodes.
Yeah, okay. And where is this Hive actually installed? On the data nodes or on the client machine?
So that the daemon service for the Hive itself, right? It is like the whole cluster you have, right? It is not necessary. It should be on a specific node. So let's say while you are setting it up, you can even decide which server, IP server you want to use, where you want to run your daemon service for the Hive one. Let's say Hive start service, right? So there will be a one daemon process which will running in the backend, which will keep on accepting your request, right? So that can be picked randomly, and that can you as well decide while setting it up on which IP address or server you want to install it.
Okay, so mostly it will be kind of the client machine only, because
yes, edge node, from the
yeah,
edge
edge
node.
node, yeah. And also, like someone asked the question that ACID is not supported by Hive, but like I browsed and it was mentioned that the higher versions of Hive like support ACID properties. So what about that?
Not as of now. See, we need to check into that one, right? Which new version has came, which is supporting the ACID properties, because even if it comes with that, you can say properties, right? It will come at a cost, right? I would have definitely compromised on something. So we need to look into that one. If you have read something, please share it with me. I will definitely have a look into it, because I didn't hear anything about it as such as of now, the maintaining the ACID properties. Then it will become like a simple transactional database, right?
Yeah, sure. I'll share the link with you now
Yes.
in the chat.
Yes, please.
Thank you.
Cool. So last 2 minutes, I'll quickly, Jay, please go ahead, quick.
Yeah, thanks, Shang. So it's, actually, I was trying around that. I mean, you were giving some assignment kind of question yesterday, right? To create a kind of external table with the PARQ and ORC, right? So I was trying for that one. Yes, yesterday. So the thing is, can I quickly share my screen? I have stored that output. I can just show you that. So maybe you can just.
Okay. Just a second. Yes, please go ahead. I have made you the host. Yeah. So you created that stored as ORC location. So this location, so in this T2 underscore ORC, which data is stored? Jay? Hello? I can't hear you, Jay. Hello?
Hello, can you hear me? Yes, yes.
Yeah, I can hear you now. So what I'm saying, in this, the external location you have, right? Which type of data is there?
Correct. So this, I mean, when I created, a normal, I mean, ORC table. Then I loaded the data in the way that how did you mention yesterday, right? Because I mean, from that query, from that particular location, then select star from that using that query. I mean, we can, I mean, from another table, from another. I'm just querying and I mean, putting into T2 ORC. So that is already an ORC kind of format, right? So from there only I can use an external. So this is a kind of always we can use like this only, right? So I mean, for example, if I have a PARQ warehouse, I cannot use an ORC, right? I cannot do. So this is my correct.
So you are saying in this T2 underscore URC, you have stored the ORC data, is it?
Exactly. Yes. I mean, if I was trying for some other some PARQ and all, but that is not working. Though I am I'm referring from warehouse, because external I mean table we always have to I mean give a location, right?
Right, correct.
Yeah. So I mean this is the some R&D I was trying, but I'm not sure if you have some more input or some other additional things that you can add. Is that understanding correct or?
No, I get it. I get your doubt. So yeah, again, this will also need little bit of digging. So whatever are your findings, right, please mail it to me, shashank@ineuron.ai. And these kind of doubts, yes, definitely need some time. So at least I will get at my end as well, that where it is failing. And if I find something or anything like that, so I'll look into it.
Yeah, thank you so much. Thank you so much. Yeah, please go.
Cool. Let's go quickly. Claim host. Next, I can see quickly. Sumit, please go ahead quickly. Hello.
ये मेरा गणेश ने जो पूछा था ना, वो डाउट था, वो क्लियर हो गया था। और
Okay.
जो रिकॉर्डिंग वीडियो थी ना, उसमें सबटाइटल की प्रॉब्लम आ रही है। जैसे इंग्लिश में कुछ वर्ड समझ पाता हूँ, कुछ नहीं समझ पाता, तो
अच्छा,
सबटाइटल्स दिख जाते तो ठीक होता है।
ठीक है, ठीक है। I'll talk to the team. कुछ करते हैं इसका भी।
जो पिछले 3 वीडियोस है ना, उनके सबटाइटल नहीं है पिछले वीडियो में।
ठीक है, ठीक है। लेट मी चेक विद द टीम, मैं बात करता हूँ। ठीक है, ओके। क्विकली सतीश, क्विकली।
Yeah, hi, Shashank.
Hey.
So yeah, I actually it was clarified, but I have a very little question. I think that Etherport, right? When we installed our machine, virtual machine, and we are trying to access that machine outside our putty, like in our from our local, right there, Ethernet 1 is not coming up, is not showing up in my screen when I did IF config.
Okay, did you check with the technical team once?
Technical team, no, I did not contact them.
Okay, so just check with them. Like we have a this kind of support available for these kind of technical issues, right? So this is something where right, that team member will spend time with you over a screen share, and you can share these problem statements, right? And they will fix it for you if anything it is related to installation or configuration missions, all these things. So for these kind of things, I would definitely recommend to connect with them. We have a dedicated
yeah, I understand.
Yeah.
Thanks, Shashank.
Okay, cool. So last one quickly from Devanshu, please go ahead. Hey Devanshu. Hello, Devanshu, are you there? I can't hear you, Devanshu, if you are there.
Hello.
Yep, Devanshu, please go ahead.
Hello, sir, I have got in a temp file, sir. I'm not able to just make temp file in my local system.
No, local system means your laptop or the Cloud Era VM?
Laptop, sir.
So laptop, you are like, you don't need to create that temp, right? If you want, you can create, like, because /temp /something starts from the root itself, right? In your local, let's say from your local terminal, if you are doing this / means you are trying to access the root. So you should have a sudo access. So how you can do it? Let's say sudo mkdir /tmp /something, right? You want to create it in the root one. But if it is all about your local, then there is no need eventually to create that one. You can create folders. It's something like /home /Devanshu /desktop, something like that, and mention that part correctly while doing anything, let's say HDFS command or anything like that, whatever you want to do.
Sir, I also am not able to just make external database, sir.
Sorry?
External database, sir.
External database, what
that one, all the process I've done, but it's not showing in Hive, sir.
No, I'm not getting when and from where and how you are trying to access the external database.
From Hadoop, I have made the database of external database, sir. From there, I have loaded the table from Hadoop to Hive. But that was it was okay, sir. But after showing the data, so data, it's not showing there. Sir. So table miss, sir.
So you are like, your data was in the HDFS, you are saying, and you created an internal table or external table?
External table, sir.
So you are saying data is, you are not able to see the data. Did you check the schema once, like the data which is stored, it is completely matching with the data set you have, right? That compatibility you have checked?
That one I have not checked, sir.
Okay, so just check on that part. So mostly it could be the issue on that part. Let's say that data is not getting matched properly with the schema you have created. So just try to look into it, and then probably it will be fixed. If not, then mail the screenshot of your errors to me, right? And I will dig into it, that what could be the reasons.
But sir, after loading the table, it's showing okay.
Yeah, so that happens. I even showed this thing to the live classes. So while writing the data into the Hive table, it do not do any schema verification, right? So that is why Hive is something, it is a schema on read. So let's say whatever internal and external data you have, when you will start reading the data, only that time that incompatibility error you will be getting. So that is the thing with the Hive, right? General behavior.
Okay, sir, thank you.
All right, so now I will not take much of your time. So I have shared the assignments, right? So make sure you complete it, do it, and also share it over the social medias. And I'll see you in the next week with that one, the remaining part of the Hive class. Until then, yeah, I'll catch you later, guys. Thanks for joining. Thank you so much. Bye bye.